Right, I think we are live. What is that? Going like that. Okay, let me just do this. Perfect. Right. Guys, we are here for the Nancy Grace Roman Space Telescope launch. And as you can see, I am in my hotel room. I'm actually in my kids' bedroom because they're all out in the front room. But yes, we are still on holiday. We were meant to be back this morning, but weather managed to cancel our ferry. So yeah, we are now stuck here for another 2 days, and we will be back tomorrow. Well, we'll actually be back Tuesday morning UK time. So yeah, I wanted to do this one obviously at home. This is a very big launch, but unfortunately I'm having to do it here. I'm trying to find my notes because this is a massive launch, and I had some great things planned as well. So I had, just below where I am, if you put in the words booster jettison or something like that, the Falcon 9 would come up, and then the two side boosters would pop off. Unfortunately, we're not going to get that because, you know, I'm here streaming from my laptop, which is, it's okay, but it's not the best, and it doesn't have access to where I put all the pop-ups and stuff like that. So unfortunately, this is the best we get today, unfortunately. And also I would have been playing GTA tonight, but I can't do that. I mean, technically I probably could play remote play because the internet's good enough here. Oh, okay, maybe we might do a little remote play tomorrow. I'm going to be on the boat by the time I would normally do it. We'll see what we're doing tomorrow. I'm just going to nick a pillow, guys. I'm just going to chuck on some background music for a second. Where I nick a pillow. There you go, make these chairs a bit more comfortable. And we're going to put a duck as our little mascot here. We got a little ducky. See if I can actually get it in balance properly. Duck's gone overboard. I'm not even going to try it. Oh, man. Oh. This is just like a little cupboard wardrobe thing. Chest of drawers, and it is really low. Right. Let's turn that off. So we are T-minus 1 hour and 16 minutes until liftoff. Oh, do you know what? I'm going to try and see if I can do it. Stream elements. I'm going to see if I can get a countdown timer on this, because I haven't yet got it done. Alright, let me log in. So we got a counter monster to get us through the stream. Oh, that was loud. Right, okay. Oh, that's cold. Right. Streaming tools, overlays, countdown timer. Let's see if I can get this to work. Right, count date. Date is the 30th. It's 12:25 is the launch time. Right, let's see if I can add a browser source. See if I can get it to work. Come on, why are you not working? Hello, why is it not working? Universal copy and paste is not working. The hell? Okay, this is like the first time ever. Copy. This is like the first time ever I've not been able to do universal copy and paste. What the hell? Why is universal copy and paste not working? Oh, okay. That is rather strange. Right, give me 2 seconds, guys. Just gonna have to quickly do this. There you go, we're back to that. OBS. There we go. Right, we are T-minus 12 minutes. Get in there. That was really weird. I don't think I've ever had universal copy and paste not work. I'm on the same Wi-Fi network. Okay, that is very strange. I'm just trying to find now my notes, my sort of bullet points that I've written down for this stream. God, I can't find it. Why? I tell you, I should really organize my notes. My notes are all over the place. The problem is that I've saved all my series stuff as notes. So it's one of them things of you have to go for it. The amount of times I ask Siri about something and then it just doesn't seem to, it logs it. Oh God. I just set her off. Right, we have 5 minutes, guys. Now, at the moment, the chances of liftoff are 50%. So it's not looking crazy, but also it's not the best. Right, I'm going to start a poll. I think my spacebar is starting to die. For some reason, my spacebar seems to be doing weird things, and I don't know why. But yes, we are almost there, guys. We are. Right. Sources can go there. Right, okay. Just moving a few things around because my chat bar is very, very small. Oh, they're coming for us. Right. Why can't I literally cannot find my notes. It's really annoying. Oh, okay. It might help if I actually search by the name of the telescope. Right. Okay. So I found it finally after ages. So we're going to go through and talk about the actual rocket itself. So the rocket itself, as you can see depicted here, is a Falcon Heavy. So Falcon Heavy is basically 3 Falcon 9 boosters strapped together in like the most Kerbal way possible, and the 2 outers are actually, for once, they are 2 independent boosters that are flown very different amounts of times. So usually the boosters are round about the same, or they're like new. So the boosters on both sides, one side will be darker than the other from the amount of carbon soot that builds up over the time of its launches. But the middle booster, the main one, that will actually be expended. Now there was the idea of landing the 3rd booster down range on a drone ship. So the 2 side boosters, they both come back for a booster landing at LZ1 and LZ, let me just double check. Oh, SpaceX Alive, okay. I would actually prefer to do SpaceX stream versus their one, only because right, I might need to change my crop here. Let me just double check. Right, let's just change my crop. Nice. Right, I'm going to quickly go grab my AirPods, because that might actually stop the music coming out the phone.
Our universe is a very dynamic place that puts on spectacular cosmic displays every second.
Ooh.
With Roman's panoramic vision, we'll not only catch these events, but we'll see many at once. And use this to uncover the distribution.
Oh, I didn't like that. Bah. Right. Okay, now you guys can't hear the sound, but that's fine, because I can do this. Where is it? Right, okay. Uh, let's move that here. The thing you didn't expect, right? Audio output capture. It's not that one. Oh, okay. Right, macOS audio capture. Here we go.
More thrilled than I can possibly explain.
Application. Safari.
More than 20 years ago.
Oh, wow.
There we go.
When we just had Roman as pencil and paper sketches, dry erase boards, PowerPoint presentations, and now it stands waiting on the
Right, okay, you guys all have me. Oh, wow. That's really, really loud. Right, let's do that. There you go. Cool. Right, so now we've got on the headphones as well, which is good. I'm just going to refine the crop on the window thing, guys.
Designed to take wide view panoramic images of the universe, mapping the cosmos 1,000 times faster than it's ever been possible.
There you go. Come on.
Wow, and that's just one of the primary instruments that are on this mission. And so
It'll look a
with
bit
this
funny for a
Roman,
second, guys.
What kind of mysteries are we hoping to uncover?
We built Roman specifically to address two pressing questions in astronomy. The first is about the fabric of our universe, the unknowable dark matter and dark energy forces that together.
Oh, come on, give me light. I can't see.
Across cosmic time. And
I can't see the right-hand side. It's
What I
dark.
find fascinating is, again, that what you just talked about, dark matter, dark energy, that makes up 95% of our universe, meaning there's so much we don't know.
We really only know, well, the 5% that we've been able to see thus far. The stars, the galaxies, the planets, you and me, that's 5% of the total mass and energy in the universe.
Wow, that truly blows my mind.
All the other portions we have yet to discover and learn enough about.
Right, here we go.
Second pressing question you said.
The second question is about planets around other stars. We call these exoplanets.
There we go.
What we'd really like to know is whether there are solar systems like our own out there, or whether ours is a common feature or a rare feature, or maybe unique.
Some really ambitious questions, but again, your team has really developed such a great tool, and we can't wait to see it in space and in action. And we will be with you today through launch and when we deploy Roman into space. And over that hour and a half, we're going to introduce you to the namesake of this mission, Nancy Grace Roman, right there. How the 11-year-old girl who started an astronomy club became a trailblazer at NASA.
Nice.
Could Roman bring us closer to finding another Earth? How its coronagraph could one day help reveal what distant worlds are made of. And how will Roman see dark energy and dark matter? Again, invisible forces shaping our universe. We're going to show you with a champagne flute. That might be surprising to people, but that's a really fun demo. I can't wait to do.
It's a little early in the morning for champagne, but we'll make it work.
I don't know. We're going to sell.
What's going on? Why does it keep...
Right,
Let's pause it.
Dominic. All right, so again, a lot
There we
to
go.
learn and a lot of ways that you can participate in today's broadcast. For example, if you have a question about anything we're talking about, just send it our
Hang
way
on.
by tagging @NASA on Instagram, anywhere where you're watching.
Oh, why is it
The
suddenly...
guy who's going to answer all those questions. Okay, we are now 1 hour, 1 minute, and 25 seconds until liftoff of Roman.
Why is it now all of a sudden started going stupid?
We'll monitor all the critical milestones to get us to launch today. NASA's Steve Seiseloff and Jared Whitaker here in Florida, and Zachary Lupin at SpaceX in Hawthorne, California.
Thanks, Megan, and hello, everyone. My name is Zachary Lupin, and I'm an avionics supply chain engineer here at SpaceX. And it's
SpaceX.
Falcon Heavy back on the pad again for its second flight this year. And of course, at historic Launch Complex 39A at the Kennedy Space Center in Florida.
Nice.
Now, this vehicle was developed entirely by SpaceX as a heavy lift version of our proven Falcon 9 rocket. Falcon Heavy's debut flight was back in February 2018 and marked the first time a rocket this powerful, with over 5 million pounds of thrust, had been sent to space by a
Yeah.
private company. Now, to date, Falcon Heavy has flown 12 times with 21 total booster
Oh,
landings,
God.
18 reflights, and 100% mission success. Now, that first flight was a demonstration mission that carried a Tesla Roadster into a heliocentric orbit around the sun. With Starman at the wheel, that Roadster is still out there today, over 50 million miles away from Earth. And that was an unforgettable day and opened the door for operational missions, including flying military payloads, giant commercial satellites, and NASA science missions like the Europa Clipper in 2024. The Europa Clipper is NASA's largest ever interplanetary spacecraft and is currently on a trajectory to Jupiter's moon, Europa.
Oh my God,
The spacecraft
Jesus.
will perform close flybys of Europa to determine whether the moon has
That was really
ability to
loud.
support life, one of the most inspired questions in planetary science, astrobiology, and frankly, humanity. And its arrival to Jupiter is expected in 2030. And we'll have
2030,
talk more
Jesus.
about the incredible science Falcon Heavy has helped enable later on in the show. Now, we're just under an hour until launch, and Falcon Heavy is getting ready to put that power and capability to work, getting the Nancy Grace Roman telescope off planet and out into space, just about a million miles away from Earth. And with that, let's
Nice.
say hello to Steve and Jared. How's it going, guys?
Good morning. Thanks, Zach. I'm
Steve and
Steve
Jared.
from NASA Communications, and with me is Jared Whitaker. He's a Senior Vehicle Systems Engineer from NASA's Launch Services Program. Jared, good to have you on board this morning.
Yeah, thanks so much, Steve. It's a pleasure to be here. Vehicle Systems Engineer, we work with all of the engineering and analysis groups in our program. We want to make sure that there's good communication between everybody as we work through any issues that might arise during the launch campaign. And then to get us here today for launch. Hopefully I can bring some background and some context
There we go. Cool.
to the launch today.
Excellent. And speaking of background,
Oh God, sounds like my
we have
child might
coming
be
up
crying.
The poll in just a couple minutes. The NASA launch manager will poll his team to see if everything is set for loading propellants, loading fuel and oxygen into the Falcon Heavy rocket there at the pad at launch.
So look at it, guys. It's dark there.
At this moment,
We're here in
not
Jersey.
working any technical issues.
It
In
is
fact,
super
the weather
bright.
has improved. We are
Oh.
currently at a 70% chance of no-go
So-
condition. A 70% chance of go conditions.
I was going to say, that's worsened.
70% go. And Jared, we're looking good so far. Quiet nets. We'll be listening to those throughout the morning, but definitely a good feel. Good
Yeah.
feel.
It's good so far. Always happy to have quiet comms before a launch. Everything's green across the board so far. Not working any issues on the launch vehicle, which is great. But definitely overall a team effort
Nice.
today, between the Roman team, SpaceX, and LSP. These three teams started working years ago when SpaceX was selected.
Yeah,
for
look, guys, look at
telescope.
the
And
booster.
so it's just a really exciting
Right.
time to
You can
see it finally
see
on launch day for everybody.
two
Excellent. We do
almost
have,
brand new
teams of
boosters
engineers,
and then one
at our
reused one.
group here
So you can
at
see the very far
Mission
left one
Directors Center here
is
at,
just pure white, center one
Canaveral
pure white,
Space
and then the
Station.
far right one
SpaceX has
is
those
quite
groups
darkened.
at Hangar X, and of course there in Hawthorne, where you just heard from Zachary. And
I might go get a
Goddard
snack,
has
guys.
a center as well, watching over the Roman Space Telescope as we.
NASA team, this is NLM on NLNet. I'm going to be conducting the propellant load and launch readiness poll. And just be advised that weather is trending favorably. Looks like right now we lowered from a 50% POV to a 30% POV. And we're currently not tracking any issues. With that, I'd like to start with NASA CE.
NASA CE is go.
SMA. SMA is go. SMD. SMD is go.
Can tell.
NASA MEM.
There.
NASA MEM is go.
LSP. LSP is
She
go.
got stuff in the buttons.
NASA is ready for propellant load and launch.
And there we have it, Jared. Launch teams are ready to proceed with the propellant loading, and with that, we will go back to Megan at the host desk.
Just Just 1 second. I'm looking for that champagne flute.
We're going to need them soon enough, Megan.
Yeah, no, that's wonderful. I mean, again, as you just heard Steve and Jared say, weather was
Right, I'm
trending
back,
at
guys.
50% go. Now we're at 70%
Where did?
go, so that's excellent news.
That's certainly the right direction, Megan.
Absolutely.
Let's keep it going.
Oh,
Okay, I was
dang.
ready with my champagne flute, but okay, we'll wait. We'll wait a little bit. All right, now,
I
Roman was
got
named after
toffee
Nancy
popcorn,
Grace Roman
guys.
and Dominic. She was NASA's first chief astronomer.
You know, she was somebody who probably was designed to be a leader in astronomy from the get-go. At age 11, she had founded an astronomy club at her school where she would take people out to view the night sky and learn the constellations. Well, that path eventually led her to NASA, where she became
That's
the one
very
who
cool.
made all of NASA's first space observatories happen. She understood that the blurring introduced by the Earth's atmosphere was detrimental to astronomy. If you could get out into space above the atmosphere, it would be so much better. She likened astronomers on the ground looking through the atmosphere like looking at space through stained glass windows.
Oh, okay.
And so she
Wow.
managed to get all these missions started, including the Hubble Space Telescope. She's known as the mother of Hubble. And so I'm thrilled that we have a telescope named in her honor.
Yeah. And
The
speaking
mother of Hubble,
again,
wow.
we're saying that Roman is going to join NASA's already impressive fleet of telescopes. And you just heard us mention Hubble again. Why don't we take a picture that Hubble took back in 1995? Hubble had launched in April 1990, and this is one of its most iconic pictures, the Pillars of Creation. And then NASA's Webb Space Telescope, that launched in December 2021, and it took a picture of that same patch of sky in 2022. I mean, Dominic, obviously there are differences here.
You can see here on the picture on the left with Hubble that it's beautiful and, of course, iconic. And most of what you're seeing is the surface of these pillars and the gas behind them. And they generate these beautiful colors, but you don't see inside.
Okay.
That's because Hubble operates in visible light. Webb operates well into the infrared, where you can see through.
Propellant load and launch go-no-go poll is complete, and we are go for propellant load and launch.
Hey, there go for propellant
They're
mode.
really quick. Yeah, that's awesome news. That would be SpaceX's team polling their folks to make sure that they also are ready for launch. Go ahead, Dominic.
Great. So on the right, we see the Webb image taken in the infrared, where you can see through those clouds of gas and dust and all the stars behind, but you also see the young stars forming inside those pillars. That's extra information that you get by going into the infrared. So you have this deep image from Hubble, you have this detailed image from Webb. So what are you missing? The wide image, the context that gives you more information, not just about that area, but about everything around it.
And so that is what Roman is adding. That's the new capability that we're adding again to this larger fleet of telescopes.
And so the three of them together can operate in concert in ways that we haven't been able to before. So imagine that iconic Hubble image, but then zoom out to 100 times the field of view. This is what Roman gives us. It can serve with Hubble and Webb to be more powerful than any of them individually.
Beautiful, beautiful images. Again, incredible space telescopes. Can't wait to get Roman off the ground. And speaking of, NASA and SpaceX are about to start fueling the rocket. So let's check back in with our commentators ahead of this terrific milestone here. Let's go over to them now.
Thank you.
Go.
It is T-minus 52 minutes and 28 seconds. Everything looking good so far for an on-time launch at 7:26 a.m. Eastern Time of the Roman Space Telescope aboard a SpaceX Falcon Heavy rocket. The teams have given their go, and they have begun the process of getting ready to fuel the Falcon Heavy rocket. There are several centers, several teams watching over everything that takes place. And Jared, we're here in the Mission Directors Center at Cape Canaveral Space Force Station, but this is just one of the spots
Falcon Heavy
where
tanks are venting
engineers,
for the propellant load.
where engineers such as yourself watch over.
Yeah, that's
This is
correct,
the launch
Steve. So
director
we're
with the
here at
board
AE,
instructions.
and we have the Mission Director Center is actually right here behind us. A lot of the NASA management.
Oh, stop
is here.
talking. Stop talking.
And then up at
There,
Goddard,
I
up the
wanted to
coast
listen to
in
that.
Maryland, there's the launch support room. That's where the Roman spacecraft team will be for today to make sure that the spacecraft is happy and healthy to be ready for launch today. And then they also see and there they are on the screen, the mission operations room. That's where the team will actually be conducting the science, the Roman engineers and analysis folks.
And throughout all of this, we will be monitoring the technical loops and, of course, We have Zach watching over proceedings as well there in Hawthorne, California. Zach, how are things looking?
Nice.
Thanks, Steve, and I agree, these Falcon Heavy launches are always super exciting. So our next
They are.
major milestone coming up is going to be the start of RP-1 loading on the first stage in just about 40 seconds from now. Now, like SpaceX's Falcon 9, Falcon Heavy is a two-stage launch vehicle. It's 27 Merlin 1D engines across the
Is
three
it
cores.
technically two
More than
stages?
5 million pounds of thrust at liftoff, equal to approximately 18 747 aircraft. Now, as we await the call out for RP-1 loading, let's
Do
take a
you
moment to
technically
meet
call the
Falcon Heavy.
boosters a stage?
Now, at the top of the
That's
rocket
actually a
is the
question.
payload fairing. That fairing is a protective shell that houses the payload, shielding it from aerodynamic heating until the vehicle is outside of the Earth's atmosphere. Once in space, that fairing is no longer needed, and the two fairing halves will separate and return to Earth, where they'll be retrieved by a
The launch auto sequence has started.
by a SpaceX recovery vessel to be reused on future flights. And we heard that call out just now, so we're going to start RP-1 loading of that first stage.
I wonder if they have to paint
Today's mission are flying for their
over
very
the
first
like
time today.
sticker things.
And within that fairing is the Roman
There
Space
she
Telescope.
is.
And here's a photo from midway
Absolutely
through the encapsulation
huge.
operation, just before the fairing halves were closed in preparation for flight. Now, right below the fairing is Falcon Heavy's second stage, which houses a single Merlin vacuum or MVAC engine. And below the second stage is the carbon composite inner stage, painted white today. And inside of that is where the MVAC engine is currently housed. Now, the inner stage connects the center core on the first and second stages. And below that, we have the 3 first stage boosters, which make up the bottom 2/3 of the vehicle. Now, those boosters are connected together at multiple points at the nose cone of the side cores, the inner stage, and the octaweb structure at the bottom. And, of course, across those 3 boosters are those 27 sea-level M1D engines total that I mentioned earlier, 9 on each of those boosters. Now, about 2.5 minutes into flight, the side boosters will separate and make their way back to Earth to perform near simultaneous landings at Landing Zone 2 and Landing Zone 40 at Cape Canaveral Space Force Station.
How is that?
And we're just about an hour away from all of that action, and there's still so much to talk about, so let's head back to Megan over
What
at
was
the Kennedy
that,
Space
guys?
Center.
On the left-hand side?
And time now to introduce another member of our team today. NASA's Leah Martin is live from a nearby viewing location with her first guest, NASA Administrator Jared Isaacman. Good morning to you both.
Good morning, Megan, and good morning to you, Administrator Isaacman. Huge day, a little bit early, but what better way, what better reason to get up bright and early?
Mike probably hasn't been asleep.
Huge day for NASA, huge day for Kennedy, huge day for Roman. How are you feeling?
Yeah, absolutely. Good morning, and I completely agree. This is a mission absolutely worth getting up for. I'm beyond excited for the NASA Goddard Spaceflight team, the NASA JPL team, literally the thousands that have come together to deliver NASA's great exploration asset right now, under budget and actually ahead of schedule. This is extremely exciting. I mean, this mission could change our fundamental understanding of the universe. Dark matter, dark energy, maybe 100,000 more exoplanets. I mean, this is a really exciting time.
Now, the nation actually has some incredibly ambitious
So this thing, you can
priorities
tell
in space,
he
and NASA is
actually cares
really
about
helping
this.
us do all of those. Talk to us a little bit about what we're seeing in the national space policy and the work that NASA is doing to be able to deliver on behalf of America.
Of course. I mean, NASA is at the forefront right now. I mean, executing under President Trump's national space policy. We are returning to the moon. Artemis 2 is just the opening act. And by the way, only a couple days ago, President Trump gives the Congressional Space Medal of Honor to those 4 hero astronauts, not to mention commissions a new National Space Academy. How exciting for the next generation of engineers, scientists, and astronauts coming. But Artemis 2, just the beginning. We got Artemis 3 being assembled right here in a historic landmark, the Vehicle Assembly Building, to launch next year. Artemis 4 for 2028, we return.
You can tell the
Not to mention
passion.
we're building a moon base, and think of all the scientific potential there. We have great additional science and discovery assets following up Roman. We've got Dragonfly coming in 2028, a nuclear-powered octocopter to go explore Saturn's moon of Titan. I mean, this goes to the heart of what we do to try and answer the question, are we alone? And are we alone in our own solar system, let alone the galaxy around us? It's just a really exciting time at NASA.
Man, well, I think you kicked us off great. The enthusiasm is certainly infectious, and we're really excited. And so with that, Megan, we're going to say go Roman.
Go Roman.
100% Isaacman had like a Red Bull or something before.
Thanks to the administrator, we are all very excited about what is coming up this morning. The teams have begun loading just at the very start of
This
loading
is
the
what
propellant
happens when you
for
actually put
the
like an
three first
astronaut in
stage
charge.
components, the central
Like
core and the two side modules
having
that make up the Falcon Heavy.
someone that's
Zach, and of course the
generally
second stage will begin in a little
excited
bit.
and
After they
you know,
start
it's not
loading the
just
fuel, then
a
they'll start with
desk
the
pencil
oxidizer.
pusher sort of
This
thing.
is an
You know,
important
he's
process, a
generally
careful
got
process, Jared.
the
Good to get it right from the
drive to
start,
do
right?
stuff.
Yeah, that's right, Steve. This is almost like we're at the gas station filling up the car for our family road trip. So if this was a car analogy, yeah, have to load up the RP1, but in your car you'd be able to just take the oxygen out of the air. But as you go into the upper atmosphere, then off into space, obviously there's no oxygen up there. So in the form of liquid oxygen, we have to take that with us to do the combustion in those Merlin engines to get Falcon Heavy where it needs to go today.
And of course, the reason for doing this whole launch this morning is to get the Roman Space Telescope into space, into a place where it can observe the universe. Roman is a very
lockslid has started.
Roman is a very large space telescope, a very large instrument poised on the top of that rocket.
Yeah, that's for sure. Roman's a huge, both in terms of importance for the agency and in terms of size. Throughout the process of Roman's build, the team at LSP here has been making sure that it'll all fit well within that fairing. It's definitely a tight fit, though, for Roman here today.
And that is something that engineers watch very carefully throughout the design process, getting everything set. So rocket looks good, spacecraft looks good, nets are quiet this morning. Zach, over to you in Hawthorne, California.
Nice.
Thanks, Steve and Jared. All right, let's take just a quick look at the weather, as it's definitely been a watch item for today's mission. There's been a possibility of rain nearby, and teams have been monitoring for possible violation of that cumulus cloud rule, which are those big white puffy clouds being nearby. But that weather has been clearing, which is great news. So overall, we're looking to be about 70% favorable for launch, and we're going to be keeping a close, watchful eye on that weather for the next 45 minutes or so up until that T0 of 7:26 a.m. Now, today's flight is part of a larger story, SpaceX's decade-long partnership with NASA's Launch Services Program, or LSP. That partnership began over 10 years ago in January of 2016 with Jason 3, the first primary science mission that LSP flew on Falcon 9. And in the 10 years since that mission, we've flown several more high-impact science payloads for NASA. And here's a couple of the highlights. The Double Asteroid Redirection Test Mission, or DART, launched in 2021 and is widely regarded as one of the most significant planetary science and planetary defense achievements of the decade. Why? Well, in simple terms, a spacecraft about the size of a vending machine slammed into a small asteroid millions of miles from Earth on purpose, and it successfully changed the asteroid's path, and you can see footage from the mission on screen. Now, overall, DART provided real-world data for defending Earth against potential asteroid impacts in the future. And one more highlight, in 2024, NASA's LSP turned to Falcon Heavy to launch the Western Hemisphere's most sophisticated weather observing and environmental monitoring system, GOES-U. The GOES-U satellites provide advanced imagery and atmospheric measurements, real-time mapping of lightning activity, and space weather observations. And it's NOAA's primary weather eye over the Americas and
Man, that's gorgeous.
And today, Falcon Heavy stands ready to carry NASA's Nancy Grace Roman Space Telescope all the way to the Sun-Earth L2 point. L2 is the Lagrange point on the opposite side of Earth from the Sun, which is approximately 4 times farther from Earth than the Moon. And this mission is a great example of how the power of Falcon Heavy enables incredible science and discovery way off planet. And it's the next chapter in a growing partnership between SpaceX and NASA's Launch Services Program that will continue to have real-world scientific impacts for years to come. Now let's head back over to Megan at the Kennedy Space Center.
Thanks, Zach. Okay, so now what we want to do is show you Roman's 2 instruments. Again, the things that are enabling the great science we've been talking to you about. So let's talk first about the wide field instrument.
So that's the primary science instrument on Roman. It's the instrument that
Oh.
allows us the panoramic imagery that make Roman so iconic. And in fact, we've got here the engineering model of the detector.
Oh
The
my
part
God,
that
why
senses
have
the
I
light,
got so
and you'll
many
see that that is the logo
spam
that we use
calls?
for this mission.
Please
Well,
add my
amazing.
number
And
to
actually,
WhatsApp.
I think
Fuck
this is
off.
interesting to point out that this is a two-scale model. Like this is the shape, size, everything.
That's it. That's
Yeah.
exactly what it is like.
Yeah, that's amazing. And then this next one over here, right behind us, this is the coronagraph.
Yes, so that's a subscale model. The actuality is the chronograph instrument is about the size of a baby grand piano.
Whoa.
And
Oh,
it
wow.
has in it a complex set of optics.
There's one of them
that carefully
downstairs.
adjust the light that's coming in to suppress the light of a star so that we can see the reflected light of a planet orbiting that star. This is probably the most complex scientific instrument NASA has ever made.
Wow, and we'll definitely talk more about it because, yes,
Definitely.
it's so impressive. And so both these instruments are on the spacecraft, which obviously isn't to scale.
Yes.
This is
Here we
obviously
have a
model.
small model of the spacecraft, and you can see here at the front end is the telescope that brings all of the light in and feeds both of those instruments. On this side, we have the chronograph. On the far side, the wide field instrument.
Oh,
They
seagulls
merge
are kicking
together.
off.
Now, this is actually too large to fit into the fairing. It has to be folded. Those solar arrays and the
Sure.
deployable aperture cover are folded so that we don't have to. We have to fit it inside that fairing. This is 18,000 pounds, the size of a school bus in reality.
Wow, okay. Yeah, I really like that we break things down. That was really good, Dominic. Thank you so much. Okay, so time now to bring back Leah, who's just across from Kennedy's iconic vehicle assembly building with Roman's senior project scientist. Leah.
Megan, we are joined here, like you said, by Dr. Mika Enri. So many of our science missions focus on things that we can see. We look at stars, we look at the sun, we even look back on our own planet and asteroids. This mission is actually focused on things we can't see. What is the significance of that? Why are we doing that? And what do you think it's going to help us learn?
Roman is going to understand or give us the data that we need to understand.
I was going to say, she
the nature of the
looks
universe.
English.
And obviously, you can't see the invisible. I mean, that would be stupid. But what we can do is we can make measurements of billions of galaxies. We can precisely measure.
Oh my God, that's
hundreds of millions of
ridiculous.
galaxies. We can precisely measure the position and distance, and we can use that to measure how the structure in our own universe has grown over cosmic time.
Oh, we've
We can
got
use
another
that
vote.
to measure how our universe itself has expanded.
Someone's also gone, oh, they've
When you
also gone,
combine
yes, it
those
will
two
launch.
pieces of information,
Okay,
we can get at the heart
we shall
of the
see.
nature of dark matter. This is matter that does not shine in normal light, so it's invisible. And dark energy, which is some weird property of the universe that pushes things apart.
Absolutely. I love the way you have explained this. I've listened to so many of the talks that you've given, and really heard the animation in your voice when you've discovered these concepts that are very big. What is it particularly that you think is so exciting about this mission for you personally?
I'm really excited. Well, I'm excited about lots of things. I mean, obviously, I wouldn't have worked on it for years if that wasn't the case. But I find the scope is extraordinary. We just have huge numbers of things. I mean, we will do a survey of our own Milky Way galaxy and find 20 billion stars. That would make it the largest catalog of astronomical objects that's ever been produced. It will give us an exquisite view into
An exquisite.
archaeology of our own galaxy. And that's just one science case. You know, who doesn't want to, well, I personally can't imagine not wanting to understand how the universe itself actually works. And then we're going to do an amazing survey of hundreds of millions of stars in our galaxy. We're going to point at a patch of sky, and every 12 and a half minutes, go back and take a look. So we're going to have this incredible movie.
Unbelievable.
And we will find with those, you know, we're not going to just monitor several hundred million stars. We're going to use those data to find thousands
We don't even
of
know
new
yet.
planets.
We don't even know yet, and that's the most exciting thing, is to find out what we don't know. Dr. McHenry, thank you so much for joining us, and Megan, we're going to go back to you.
Thank you.
Thank you to you both. Now we are 37 minutes away.
Sounded like they
from
cut
launch.
her off a little
Status
bit there.
Update on the launch countdown from Stephen Jared.
Thank you, Megan. Weather forecast is looking good. Well, it's improving anyway. We are currently at a 70% chance of go conditions this morning.
Nice.
So far, everything's pointing to an on-time liftoff at 7:26 a.m. Eastern Time of the Roman Space Telescope.
7:26. So they are.
So, Jared, what we're of course watching the weather on the ground here, watching the weather through the flight path, but you also want to keep an eye on conditions in space.
Yeah, that's for sure. Yeah, so there's a thing that we call COLA, or collision avoidance, and it's pretty much just what it sounds like. You want to definitely avoid hitting anything on the way up into space today. So we work with the Space Force for each and every mission. A few hours before launch, they actually track everything
Look
in
at
space,
the
from the size
look at the
size of
starship
satellites all the
pad
way down to about the
behind.
size of a baseball.
And you know, when you think of a baseball, pretty small compared to a rocket like this, but a baseball traveling at 17,000 miles an hour could do a lot of damage. And so we're keeping an eye on that, and also keeping an eye on the flight path up ahead is Zach and his team at Hawthorne, California.
Thanks, Steve and Jared. So our next fueling milestone coming up is going to be stage 2 RP1 load start in just about under 30 seconds from now. So as of now, we've been loading propellant onto our first stage boosters.
Let's go.
About 15 minutes for RP1 loading and 10 minutes for LOX, but we still have to fuel the second stage. Our fuel loading is done in phases, and that's very intentional. The 2-stage rocket you see there on your screen is primarily made up of large tanks to contain the super chilled RP1 and LOX. And as we perform fuel loading of our stages, we need to very closely monitor the changing temperatures of those stages. Now we should...
Stage 2 RP1 load has started.
And right on time, so we are now beginning RP1
Nice.
loading of the second stage.
Let's go.
And with that, let's discuss reliability, which is the foundation of every SpaceX launch. When a payload represents years of work and hundreds of millions of dollars in investment, the launch vehicle has to deliver every time. SpaceX has spent more than a decade building that kind of dependable performance, which has given NASA reliable access to space across a wide range of mission types. By flying boosters multiple times, SpaceX has lowered the cost of access while increasing the amount of flight heritage available for critical NASA payloads like the Nancy Grace Roman telescope today. Now, this kind of reliable launch access is what turns ambitious science concepts into actual data and discovery, and SpaceX will continue to provide this capability safely and consistently. Now let's head back to Megan over at the Kennedy Space Center.
Thank you to our launch
We
commentator.
haven't had a
NASA's Goddard
explosion
Space
in
Flight
quite a
Center led
while,
the
actually.
assembly and testing of Roman, which of course, no easy feat, right? Imagine building a camera the size of a school bus, launching it on top of a rocket, sending it out 1 million miles away, and expecting it to take pictures precise enough to study large portions of the universe. Well, it took hundreds of people years to figure
Look at
it
that.
out. So, of course, a big part of making sure Roman was ready to go was to simulate the intense vibrations of liftoff. You see video here, Roman on massive shaker tables at Goddard. Also, an acoustic
I would
chamber
love to stand
that
on one of them.
recreates the deafening roar of launch. And then finally, a thermal vacuum testing chamber that resembles the extreme temperatures in space. And then in June, Roman was driven to Baltimore and put onto a barge. It arrived 9 days later here at Kennedy Space Center. NASA's Steve Seiseloff shows us the spacecraft's final stop here before it got packed into the Falcon Heavy box.
Slice-off. That's a really coll name, Slice-off.
I'm here with Ryan Beamer, Launch Site Integration Manager for NASA's
Slice
Launch
off.
Services Program, and we are in front of the PHSF, which stands for
Payload Hazardous Servicing Facility.
We are on the outside of this building. It's obviously huge. We're going to take you inside and show you why it's so important for a spacecraft like the Roman Space Telescope to come here right before launch.
So I'm guessing that turns it
Anybody
upwards.
who comes close to the Roman Space Telescope has put on a lot of protective gear.
Ryan,
Isn't it crazy, like Starship? No one wears this sort of stuff.
That's true. Along with fingerprints, we're worried about
It's
things
crazy.
like hair and skin particles coming off of humans. So while we're in here working on the spacecraft, we wear these full body covered suits. One of the new additions related to Roman Space Telescope is upgrading the air shower for this facility. It blows nice clean air across us to knock any extra particles off of us.
And you know, one
That's
of the first things
crazy.
that you notice when you come into this high bay is there's a lot of specialized hardware. What are some of the critical operations that you go through to get Roman ready for launch?
Well, once Roman shows up, we need to make sure that it survived its journey across the country. So we did a long functional test for the electrical and computer systems on it. After that, we moved into the fueling operations to put the fuel into the spacecraft, which can be quite hazardous. We use a special fuel called hydrazine for this particular mission. We have to work pretty hard to make sure that our technicians are safe while they're working with it. The PHS
It looked
launch
like they're
is
going to
basically
space
the last
themselves.
place where we get hands-on with the spacecraft before it goes to launch. So that means that it's the last chance we have to make sure everything's working. It's also when the spacecraft's at its most vulnerable. So we need to make sure that this building will not in any way impact the science that the RST is going to do once it gets to space.
Of course, this building was built in 1986. A lot of missions have been serviced right over there in the same place the Roman is now. What are some of those missions that stand out to you?
The Mars rovers, Curiosity and Perseverance, both of those have come through this facility. It was uniquely suited to support their radioactive fuel that was on board, and also the cleanliness that was required.
Excellent. Well, thanks for walking us through, Ryan. This is a unique facility, and I know there's a lot going on and a lot to be proud of.
Now we ask you to send any questions you might have about today's mission, so let's answer one now. Are you ready?
I'm looking forward to it.
Okay,
What
great.
do we have?
So the first one is actually from YouTube, and they said, I have to know, why are the main imaging sensors in that pattern and not laid out like a rectangle?
Ah, that's a great question. A typical telescope focuses at its best at a point. The Roman Space Telescope was designed for a wide field of view, and so we use a different optical design where the best focus is actually a circle.
Oh.
And that's where you get the sharpest images. And what you see here is an arc that's a segment of the circle that we've illuminated. We could have made it rectangular, but it would have been slightly blurrier at the upper corner and not as good. So we've made it this way because that's the sharpest image that we can get over such a wide field of view.
That was a really great question, because again,
I
people
loved it.
might just think, well, you know, like we can, you know, make a nice design for it. Maybe this is what you want Roman to be known and thought of as, but really there's a scientific reason for it.
This is
a
the
proper
optimal way
reason.
of building this instrument.
Perfect. Great questions. Again, keep them coming. All you have to do is tag @NASA wherever you're watching this. And actually, now we have a question for you, because we are so interested to know, what are you most excited for Roman to study?
And we're going to give you 4 options. The first being the dark energy and dark matter questions.
Dark
How did the
energy.
universe form and evolve? The second one, about planetary systems. How common are solar systems like our own? The third, for supernovae. These are exploding stars that we can see with Roman halfway across the universe and use it to understand the universe. And then finally, black holes. These are the mysterious objects that are
We
so
kind
hard to
of already
detect that
know.
Roman can find them using its unique wide vision.
Yeah, kind of hard to choose, but we are asking you to choose. So go to NASA's
I'm
Twitter
going
account
dark
and vote.
energy and
We're
dark
looking forward
matter.
to sharing the results
100%.
of today's broadcast. Okay, and we're also so thrilled to see so many of you on this journey with us. Already more than 1.3 million of you decided to send your name to space with Roman. And that includes the
I did
Artemis
it.
2 crew, actually, as well as a few of the Artemis 3 astronauts. All names are uploaded to an SD card, and that card is part of that commemorative plaque you see on your screen there. It is affixed onto the spacecraft. And actually, speaking of Artemis, it's full speed ahead as teams get prepared for the next crewed Artemis 3 mission next year.
Someone pressed the wrong button there. Artemis Moon Minute. Here we go.
The Artemis 2 crew has officially passed the baton. NASA astronauts Randy Bresnik, Andre Douglas, and Frank Rubio, as well as European Space Agency astronaut Luca Parmitano, will fly next year on Artemis 3. They will get to space the same way as their predecessors, inside an Orion spacecraft atop NASA's Space Launch System, or SLS rocket. Teams are already assembling parts of that rocket as we speak.
It is mental how quick they've ramped up SLS production.
Vehicle assembly building, and the 4 RS-25 engines, those arrived at the spaceport this summer, and the massive core stage arrived in April. As for Orion, technicians already installed its heat shield, and now it is attached to its service module, which supplies the spacecraft with electricity, propulsion, and air and water. Kennedy's launch team already hard at work, conducting monthly countdown simulations to make sure they're ready for launch. Artemis 3 will take the 4 astronauts into low Earth orbit to practice docking with test versions of commercial lunar landers.
Oh, look at that, Starship.
Landing
Blue
Artemis
moon.
4 astronauts on the moon in 2028. That's your Artemis Moon Minute. companies developing those lunar landers are Blue Origin and SpaceX. In addition to docking, up to 2
Why are their
astronauts will
eyes
enter
like
the Blue
really
Origin lander
like
to experience the crew cabin
piercing?
and its environment. Zach and Hawthorne now has more on SpaceX's plans.
Thanks, Megan. The Artemis 3 mission is the final test before Artemis 4 attempts to put astronaut boots back on the moon for the first time since 1972. Now, SpaceX will be
Boots on the
launching a
moon!
Starship with a docking port on the nose so we can practice rendezvous and docking with the crew. One key test objective
So I
comes
take
after
it
docking, where we'll be able to test out maneuverability of the vehicles while connected. And this has new importance as the revamped plan for Artemis 4 uses Starship to do the burn, sending astronauts to the moon from Earth orbit. And another cool addition, NASA is putting 2 SpaceX mini lasers onto Orion to connect it to the Starlink constellation, with the
lasers.
goal of enabling 4K imagery and video from the spacecraft while in space. Now, there's definitely lots of excitement planned for next year as SpaceX and NASA work together to send humans back to
So
the
with
moon.
Starship,
For now, though, it's all about the Roman Space Telescope and
they're
learning
docking
more
at the
about our
top.
universe. So back to you, Megan.
So I'm
Zach.
guessing
Okay,
that
so again, we want to talk about these
it's
why
gonna
missions.
be
Why is it such a game changer? Think about it
not
like this.
recoverable
Our
because
production
that's
team, they
where
actually made us
the
these special
header
glasses.
tank is.
You're going to notice just very small holes for our eyes. These focus our views, so right now all I can see is actually myself on camera because that's how production and live TV works. So, but I can only see that, right? I can't even tell that Dominic is next to me if you weren't talking, Dominic.
I'm over here, Megan. But I can only see your face, and I can't see anything else around you at all.
And so what we're going to do is mimic this focused field of view for you guys at home. See, so all of a sudden we're gone, right? All you can actually see is the top of our desk. But again, open it up. We're going to open up our glasses that we have on our faces here. Look at what widening the view does. Now I can see Dominic. Hello there.
Hello, here we are again.
We can see
we
the
can see
desk.
everything.
Yeah, exactly. We can see our props here. We can see
Oh,
our
this is so
laptop.
cringe.
So explain now how that relates to Roman, why widening out our view is so incredible.
Megan, we're able to get a big picture, and by that I mean the quality is in the quantity of data. Rather than looking at one object and understanding it, we want to understand the host of objects, understand the big picture of the universe writ large.
And also, you know, I've heard Dr. Julie McHenry say this all the time, you know, our universe is such a dynamic place that it's so hard to capture it all at once, but actually Roman will allow us to capture more.
Well, there are objects in the universe that are changing all the time, every second. Stars and galaxies that you have to know to look at. But we have a wide field of view, so we'll be looking at millions of them all at once and understanding them in an entirety.
Wide, but still very detailed.
Oh,
How do we
God.
accomplish that?
We had to make a camera that was able to achieve the same kind of detail, sharpness of image that you get with the Hubble Space Telescope, but with a much wider field of view that allows us to capture all those celestial objects. We could only do this because technology has allowed us to make the largest infrared detector in the world.
This.
Indeed. And so I'm going to start by saying, well, everybody knows what a camera's like because they have one in their pocket every day.
Me
Their
2
cell phone.
seconds, guys.
Everybody's cell phone camera has a detector. That's the part, Megan, that turns light into electronic signals that we then interpret as the actual image.
Okay.
I have here a very small detector for a modern cell phone camera. It's a 12 megapixel sensor. And the actuality of the sensor is this tiny little black square in the middle.
Right there.
That
Wow.
little bit is the optically active part that turns light into signals. That little part is everything that we have to make all the beautiful images that you can take with your cell phone. Now, Roman has to do that job over a much wider field of view. I'm going to hand this to you, Megan,
Okay.
and just compare it to the entirety of the Roman focal plane. That detector that you see there is 300 million pixels, and the pixels are larger, so they gather ever more light. They are able to see objects halfway across the universe because we have all that same detail that you'd expect, but so much more information than we've ever been able to acquire before.
Sure. Cell phone camera, Roman. Incredible.
Exactly.
And actually, thinking about it in that way, then when Roman takes its images, I mean, at full resolution, these images will be ginormous.
The smallest Roman images will be 1 billion pixels.
Oh my
When we
gosh.
take a 1 billion pixel image, there isn't a screen on Earth large enough to display all of that at once. And that's a small image. The largest Roman images will be 1 trillion pixels. If you wanted to view that on 4K monitors. You would need 500,000 of them tiling 45 city blocks to
Whoa.
have a single large Roman image encapsulated at once.
So then how do you study an image that large? Are you
Well-
going to buy all those 4K cameras and lay it out in Central Park?
Megan, I don't think we have a budget for that many monitors necessarily. But we do have a lot of people, interested astronomers and citizen scientists around the world who would love to have access to this data and can help identify interesting objects and can help machine learning to train computers how to do this so that computers can do this for us.
Great, 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 great. Technology really advancing what we can do in the scientific community.
It's on the cutting edge of what is possible
All right,
today.
I'm back.
Perfect.
Sorry, guys.
Okay, we're getting new updates on fueling, so let's head back
Oh,
to Steve.
we're
and
at
Jared.
T-minus 20 odd minutes now.
We are looking good this morning. We are at T-minus 20 minutes, 45 seconds. Fueling continues. We are about 80% on the first stage boosters when it comes to fueling, about 70% or so with the oxygen. And we do have stage 2 fuel load complete with that call. Jared, we're continuing to move toward an on-time liftoff.
Yeah, once again, still been very clean on the boards. No warnings or alarms or anything coming up. Always happy to see that. LOX load should start here in maybe a minute and a half or so at 18:30, and then that'll be. We'll also hear call-outs for completion of RP1 load and LOX load a little bit later as well for the boosters.
And we've been watching, of course, the rocket loading to boost the Roman Space Telescope. The spacecraft itself was fueled completely some time ago.
Yeah, probably about a month ago or so. Roman was filled with what they call hydrazine. It's a hypergolic fuel. They use that in their
Hypergolic fuel.
What we would call station keeping around that L2 point, about 1 million miles away from Earth.
And when you think of a satellite out in space, out at that Lagrange 2 point,
Right, I'm going to see if I can get
hydrazine
the...
comes in handy just to kind of station keep in that orbit, as I understand it.
Yeah, that's right. It's for probably at what I would say is like the larger movements of the spacecraft itself. But when you want to get down to really pointing precisely to get those nice still pictures and gather all that light from deep space, you really need to use the spacecraft's gyroscopes, or reaction wheels is what they would refer them to.
Right.
Those are there to make the very smooth, very precise pointing adjustments to really look into deep space and get that clear imagery of the cosmos.
Excellent, excellent. So we are T-minus 18 minutes, 57 seconds. All the systems are looking good. Weather continues to trend positive. We remain 70% go.
All right, sweet.
And
looking pretty good,
so
guys.
things on the Space Coast are working towards...
All right, my timer will come back in 10 seconds.
And with that, we'll go back up a few miles near Launch Complex 39A for Megan and Dominic.
Oh.
Stage
Hello
2
there.
LOX load has started.
LOX load starting here as you are looking at our iconic countdown clock. 18 minutes, 22 seconds until liftoff. Right in front of them, a crowd of people there. Oh, they have signs. Again, just a sampling of all the people who are here for there they go, they got their cue.
Oh, I love it, I love it.
A sampling of all the people here who are in
All right, I'm going to get that close enough.
here for today's launch. Really excited again as we just heard that fueling continues with LOX loading.
Oh, goodness sake.
The vehicle. Again, here we are for Roman's launch. Just as
This is so annoying.
A wonderful day. You were saying before that this is 20 years in the making for you.
It's been a long time getting here, Megan, and it's thrilling to see so many people in the crowd here, so many who want to see this, who are just as thrilled about it as I am.
And so Roman could change literally everything we know about our universe.
Roman was designed to address key questions that people have asked for a very long time.
Mm-hmm.
One of them
There we
is
go.
about exoplanets and whether there are planets out there and solar systems out there like our own. That situates our place in the universe.
Of course, yeah.
The other is about the biggest questions on the grandest scale, the fabric of the universe, how the universe that we see around us came to be, pushed and pulled by the competing forces of dark matter and dark energy. These are mysteries that Roman was designed to settle, and I cannot wait to see this launch so that we get those answers.
And how do you study
Nice.
mysteries like that with two impressive instruments, right?
We did build Roman with two fabulous instruments. One of them is the wide field instrument, and we have the iconic camera with our logo right there. The second is the coronagraph instrument, perhaps the most complex instrument and capable instrument of its kind that can measure the reflected light of planets around other stars.
And so the coronagraph, this is a smaller model. Obviously, the larger one, as you've said, is closer to the size of a baby grand piano. Actually,
That's
there's a check in
mad.
here. This is the actual size. So just really cool to have these visually.
Oh, wow.
verified.
Yes, that is the actual size of the detector. Of course, it's in a camera that's the size of a commercial refrigerator.
Oh my gosh. Okay, so speaking of the coronagraph, NASA Jet Propulsion Laboratory in California led the design, construction, and testing of it. Leah is back this time with Jason Rhodes, a cosmologist at JPL.
Good morning, Megan, and good morning, Jason. Thanks so much for joining us all the way from JPL. It's great to have you with us today. So this isn't the first coronagraph that is actually launching into space, but it is the most powerful. How so?
Well, the Roman coronagraph will be about 100 to 1,000 times more powerful than any coronagraph flown in space. And this is because the Roman coronagraph is going to use a number of new technologies debuted together for the first time in space. These include technologies like single photon counting detectors. When you're counting about 100 million or 1 billion photons from the very bright star, for every single photon you get from the planet, each of those planet photons is precious and we want to capture it. Another of these technologies is these small deformable mirrors, about this big, and these deformable mirrors have about 2,000 pistons over the mirrors that allow us to change the shape of the mirror. And by changing the shape of the mirror, we're able to correct small imperfections in the telescope or the optics to put the starlight away so that we're only capturing the planet light on the detector. And we're going to do great science with these new technologies on Roman, but the real goal is to test them out for possible future use on a future coronagraph that would use these to look for signs of life around planets outside of our solar system.
So now,
Nice.
so this coronagraph will actually conduct a series of observations. So when you get those first images back, what are you hoping to see?
Well, the first thing we hope to see when we use the coronagraph is essentially nothing at all. If the coronagraph is working correctly and we point it at a bright star, we're not going to see any of the star's light, and that means it's working. So we're going to be excited to see essentially nothing at all. But really then what we want to do is we want to move the coronagraph from that bright star that we're using to calibrate it to a bright star that has a known planet. And while the Roman coronagraph won't be able to look at planets as small as Earth around sun-like stars, it will allow us to take the first images of a planet like Jupiter around a sun-like star in reflected light. And that is going to be an amazing science opportunity, but it's a huge step forward in developing these technologies that are going to be used on a future coronagraph to look for signs of life around exoplanets. So it's within my professional career to be able to search for life outside of our solar system.
Great, Jason.
Nice.
Thanks so much for being here today. And Megan, we're going to send it back to you.
Thank you to you both. Now, Roman will take its pictures from a special spot in space called
Lagrange
the
Range
Sun-Earth
2.
Lagrange Point 2, or L2, and it is way farther from the farther than the moon is from Earth. It's actually 4 times farther. Why there?
Well, it's about 1 million miles away, so that from its vantage point, the sun, the moon, and the Earth, which are bright and hot objects, are all to one side, and we keep our solar arrays so that that makes shadow where we are and where the telescope is, and so we have a relatively unobstructed deep space view of the darkest sky. We can be very efficient in our observations because there isn't a bright star or a bright planet in the way.
Okay, gotcha. And then it actually won't be alone there. We have Webb at L2.
For the same reasons, the James Webb Space Telescope was also sent out there. But you don't have to worry. Even though L2 is a point, neither observatory goes just there. They actually do an orbit around that point, and that orbit is larger than the moon's orbit around the Earth. So they're very far apart from each other. It's totally safe.
Okay, perfect.
Oh,
We
God.
did get some questions about that, so we did want to address it. All right, so then, Dominic, when can we expect to see Roman's first images?
So when we send Roman out there 1 million miles away, it will take about 3 months to get out to that point, during which time we are turning on the instruments, aligning the telescope, calibrating everything so that we are ready to begin efficient observations as soon as we're there. So we anticipate being able to do that towards the end of the year, and then we will release first light images in early 2027. all of the Roman data go public right away, Megan. We will be processing it as quickly as we can. Almost 1.5 terabytes of new imagery every day, going live to the entire world as soon as we can take it.
Wow. Yeah, that's going to be really exciting for a lot of people, again, across the world who are interested and could learn so much from this data. So I think it's a great time to also tell people about Roman's Adopt a Pixel campaign. We're announcing this campaign for the first time on this broadcast.
Adopt a Pixel. What?
One Roman image will have trillions of pixels. So we are inviting you to sign up for one of those pixels by visiting nasa.gov/adoptapixel. Imagine that, Dominic, your own piece of the sky.
Yes, and everybody can have their piece of the sky and see what's there.
And so this mission, again, named after Nancy Grace Roman. In 1960, she became NASA's first chief astronomer and the agency's first woman to hold an executive position.
Wow.
She championed putting telescopes in space, which paved the way for missions like today.
The first encouragement I got was in my junior year at college, when the head of the physics department came up to me in lab one day and said, "You know, I usually try to talk women out of going into physics, but I think maybe you might make it. So pick something that you want to do." In my case, I wanted to do astronomy, and I'm very glad that I did.
And we're very glad that she did too. Okay, 10 minutes, 18 seconds and counting until
Look at the Starship Tower behind.
Space telescope
It just
launches.
looks so menacing.
Now for a question from our live audience, actually. Remember that group we showed you earlier today? They were holding signs and everything like that. One of them actually sent in a question.
Great.
So let's read that question
What
now.
have they asked us?
This is Nicholas Venuti, and he wanted to know, Roman is named after Nancy Grace Roman, as we said, who believed in the Hubble telescope before anyone else. So that being said, if she could witness launch today, what do you think she would be most excited about?
Astronomy has moved on such a lot since she first conceived of the Hubble Space Telescope. We didn't know about exoplanets. We didn't know about distant black holes. We didn't know about dark energy. All these things are new. And I think what she might be most excited about, and perhaps what I'm most excited about, is that when we take these wide-field panoramic images of the universe, we will be seeing areas of space that have never been seen before. We'll be seeing the far side of our galaxy in detail for the very first time. What new things will we discover that we don't even conceive of at the moment?
Sure.
What questions will Roman answer that we don't even know how to formulate yet?
Yeah.
That's what's going to make this mission transformative and a civilization-scale experiment.
Absolutely. I completely agree with you. That's what I'm most excited about. Again, some of those questions that we don't even know to ask. So, okay, let's take another look at the clock here. We are 8 minutes, 52 seconds and counting. Dominic, we've talked about this before. In 5 years' time, what do you hope we learn from Roman?
Well, with Roman, we know we're going to answer some of these questions, the fundamental ones. Are we alone? Is there a planet like the Earth out there? What is the fabric of space and time made of from dark matter and dark energy? We are going to get those answers in that sort of first 5-year survey. But we're going to have so much additional data that we're going to make...
Damn, look at it. It looks so mean.
My greatest hope is that everybody worldwide engages in this data, helps us learn from it, helps us understand it, helps us analyze it, helps us make discoveries far beyond anything I could ever have imagined when we got started on this.
So, Dominic, let's get Roman to launch. You just heard that call out for RP1 loading completion. So let's take you guys through the final moments of the launch countdown with Steve and Jared here at Kennedy and Zach and Hawthorne.
Let's go, guys.
We're getting into those final minutes before launch, and it's definitely getting exciting. Now, coming up shortly, we should be hearing a call out for booster engine chill in just about 40 seconds or so. And that means that the 27 M1D engines on the center core and side boosters will be undergoing chill-in with locks ahead of launch. Now, liquid oxygen on board Falcon Heavy is chilled to over 300 degrees below zero and is flown at a low flow rate through the engine plumbing and piping
that is
prior to ignition.
Very cold. The Starship Tower is right behind this.
When the ultra-cold liquid starts moving at high flow rate during launch. And as we have been loading these chilled propellants, both LOX and RP1, the temperature of
you
the
can actually
tanks
see,
has
guys.
started to drop considerably, and that's what's leading
So
to
that
those
was
white
on the
clouds that we
tower.
can see coming off the rocket. Those clouds and vapor are from the warm, humid Florida air coming into contact with the really cold walls of the rocket, but is entirely normal and is just like
Aw,
when you see
man.
breath on a cold winter day.
That's so annoying. Go on, change back to that.
And there's that call
Change
the
back
engine
to
2
that
has
bloody
started.
view. Go on, change back to the view.
And coming up in less than a minute, we'll hear the call out that Falcon is switching over to internal power. And this means that we're disconnecting our external ground electrical supplies from the rocket, and it'll then be entirely running on its own onboard batteries. Now, up to this point, power has been routed to Falcon via the transporter erector.
NY fuel load complete.
The transporter erector, or TE, that you see there next to the rocket.
Oh, come on,
that
go
TE
back to
does
the
a
other
lot
one.
of heavy lifting as it rolls our Falcon Heavy rocket out to the pad, raises it vertical, and stays connected to the rocket through the final seconds before launch. The TE also provides
It's not going to show
power,
us.
telemetry, and command connections between ground systems and the vehicle.
Come on, baby. Falcon Heavy is about to launch. Oh.
We are 6
Oh.
minutes from the launch of NASA's Roman Space Telescope.
I was going to say that
SpaceX
just went
Falcon Heavy
quiet.
rocket Fielding going well this morning, both on the boosters and on the
Here we go.
stage, as well as stage 2.
So that is the tank farm
Stage 2.
for the.
And Jared, we can see
there you
some
go.
of that
There's the
venting
tank farm
that, Zachary was just,
for
just
the
explaining there
Starship
in
Tower.
Florida sun.
Yeah, that's
We're
for
going to
sure.
see
Definitely
come.
lots of
It's
cold
going to be
liquid oxygen on that
mental
rocket, and we've had plenty of
to
rain
see
here
that
lately
go.
in Florida. Luckily,
It's going to be
looks like the weather's clear,
crazy.
as you can see. We're still green on the range as far as weather's concerned, and the weather radar looks pretty good. So I'm thinking that we shouldn't be constrained by the weather today, this morning. So that'll be great.
And launch specialists like yourself, you kind of enjoy this this silence that we're hearing on the nets this morning, because really means they're not discussing any technical issues. The call-outs that we're hearing are the usual ones that we
Falcon
would
Heavy
expect.
tanks are pressing for strong back retract.
Hey,
Yeah,
here
for
we
sure.
go.
Yeah, we just paused there for strong back retract call. That Falcon Heavy is getting pressurized, and so that you're pretty much getting up to your flight pressures, make sure that the vehicle's nice and sturdy. As Zach mentioned before, that TE, or the transporter erector, rolls the Falcon Heavy out from the pad and then takes it vertical. But a little bit later here, in just maybe 15 seconds or so, you'll see the clamp arms up near the top. They'll actually pull away from the top just below the fairing there.
Strong back retract has started.
And then we just heard the call out for strong back retract starting, which is great. That's pretty much just it'll recline a few degrees just to get out of the way for when Falcon Heavy lights and hopefully goes off to space here in 4.5 minutes.
Oh my God, I got another one.
And as the launch pad machinery gets ready into its launch positions, we are expecting the NASA side, the NASA launch manager, to conduct.
NLM, it's LD looking for the NASA status check.
Yeah.
This is NLM. NASA's go for launch.
Good words there from the NASA launch manager. Go for launch this morning. We are at T-minus 3 minutes 45 seconds.
Where the bloody hell is it?
Toward an on-time liftoff just after 7:26 a.m. of NASA's Roman Space Telescope.
Yeah, that NLM poll is a really important one. That's the NASA launch manager, like you said, given SpaceX launch director.
Who the hell is
the
that?
NASA team is ready. Behind the scenes, the NLM would have gone and polled his engineering team, the spacecraft team, safety and mission assurance, everybody on the NASA side to make sure that everybody is green and everything's looking healthy, which is great. And then, as you heard, he is go for launch. So we are go for launch for NASA.
Ooh, we go for launch, guys.
And we have, as the rocket continues to put its final propellant on board, we
Damn, that looks so beautiful,
also
guys.
know that the spacecraft sitting on top of the nose there, that's heading into space, that is on internal power. So it is running off its own batteries. Of course, it's covered up by the fairing, but it can run on those batteries for a little
Stage
bit.
1 launch load complete.
Nice.
Before it has to pick up some.
Honestly,
of the
Starship Tower
For
just
sure. We
looks
just heard on the
absolutely
leak,
mental.
LOX load is complete for stage 1, which is a great sign.
So we're going to go back to Hawthorne and Zach for the last 2.5 minutes before launch.
Nice.
Yeah, thanks, Steve. So coming up in just about 20 seconds from now, we should be hearing the call out for stage 2 LOX loading completion. And at that point, the Falcon Heavy will then be fully loaded with nearly 3 million pounds of propellant comprised of RP1 and LOX. So we should be hearing that call out for
Stage 2, lock slow complete.
and there's that call out right on time.
Here we go, guys. We're
Now,
2 minutes
shortly,
away from
we'll
launch.
be hearing a call out for closing out of gaseous systems, called out as ground gas closeouts, and that'll consist of topping off tanks.
Right, I'm
and
going to
filling
end the
vents in
poll,
order to
guys,
maintain pressure
at
in the
T
vehicle.
minus
And we
30
should be hearing that
seconds.
call out in just about
So if you're
15
watching,
seconds or so.
get your votes in.
And weather, of course, is now looking beautiful there in Florida. And we're right on track for launch in just about a minute and a half from now.
Ground gas closeouts.
And there's that call out for ground gas closeouts. Now looking ahead at the T-minus 1 minute mark, Falcon Heavy will enter startup and the onboard flight computers will take over the launch countdown and both
Nice.
stages will begin pressurizing for launch.
Imagine if, like,
So
two
we
of the
should be hearing that
boosters,
startup
like,
call in
start,
just a few moments.
but, like, the center core doesn't. And I wonder what would happen now. Oh, we've got some votes coming in. We've now got yes.
And there
Okay,
it is. Falcon Heavy
sweet.
is now in startup, and those flight computers are in control.
So now
now.
yes is in
So
the
we're now just
lead.
waiting
Come on,
the
guys,
final
get your
go,
votes
no-go
in.
from the launch director for today's mission.
I'm going to end the poll in.
Director is go for launch.
I will
And
go
great
for
news there,
launch.
the launch director has given the final
Launch
go
will,
for
the
today's
poll
mission.
will end at
So
T
let's sit
minus
back and
30
watch as
seconds.
Falcon
Is 7
Heavy
seconds,
takes the
guys.
Nancy Grace Roman Space Telescope to
Here
space.
we go, and poll is closed.
T-minus 30 seconds.
Let's see who wins today. Oh, it's gone quiet. It's gone quiet.
T-minus 15 seconds.
Here we go.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
And
liftoff. Go Falcon
we're
Heavy
going,
and
baby.
Go Roman Space Telescope.
Damn, look at
NASA's
that.
Roman Space Telescope on a mission to revolutionize our
Vehicle is
understanding of
pitching
the universe.
downrange.
Damn.
All M1D chamber pressures are nominal.
That is crazy. So this is the normal view we get from the booster on a normal Falcon 9.
Beautiful launch so far, Steve. Great shot there from on top of the rocket looking down, and then now tracking up, looking at those 27 Merlin engines.
Oh, look at that.
And Roman Space Telescope off into space.
It's looking good, guys.
Falcon Heavy soaring.
Power and telemetry nominal.
Hopefully we don't get a max Q breakup like we did in China or Japan or wherever the hell it
3
was.
seconds into this flight, rocket will be heading into max Q.
Falcon 9 is supersonic.
Picking up speed and altitude very quickly.
Nice.
Engines will throttle down.
What's that say? Oh, G-force, right.
Mechanical pressure.
This looks, the interface down the bottom looks so clean. 3 parts on each side. Looks so clean.
And we heard that call out for max Q, which is the point of maximum aerodynamic pressure as the rocket is ascending. Now, coming up in just under a minute from now, we're going to have a large series of events happening back-to-back. We'll be starting with BECO, or booster engine cutoff, where the engines on those boosters will power down. We'll then have side core separation of those 2 boosters. Followed by that, we will then have MECO of the main core. And then stage separation of that, as well as second engine start 1 following that. Now, those 2 boosters will be heading back to Florida today. They'll be doing boost back burns to put them on trajectories back towards Kennedy in Florida.
Kennedy in Florida.
Getting that call out for BECO in just about 13 seconds from now.
So it's going to be weird again seeing one booster land further down the Cape and then one at the further up near towards where it took off from. My child in the background, yeah.
Side booster separation
Right.
confirmed.
Here we go. Look at that.
And there we saw stage separation, and you can actually see the view from the main core on the left, and then the 2 side cores on the right-hand side of your screen.
Oh, that's sick.
Boost back started.
Actually saw the
And there's confirmation of the boost back startup on those 2 side core boosters. So at this point, both Falcon Heavy side boosters are performing their boost back burns, which is the first of 3 burns each side booster will undergo on the way back to Cape Canaveral Space Force Station.
Is that the? I think we can see the moon over the left-hand side.
Reorient the side boosters onto the required return trajectories, and this is required in the event of a return to a launch site as opposed to a drone ship ocean recovery. And today they're headed towards landing zones 2 and 40 in Florida.
Hello, EVDV. Welcome, sir. Welcome. I hope you're doing well.
Its nominal trajectory.
I'm currently still in my hotel because our ferry got cancelled yesterday due to bad weather. So I'm here for 2 extra days. What a shame, eh?
And then they'll throttle down, and we'll have our MECO, our main engine cutoff of that, and then we'll have stage separation of this center core and the second stage shortly thereafter.
Here we go.
NY boost back shutdown. MECO. Stage separation confirmed.
Nice.
And great shot there as the first, main core and second stage separate from one another. And we just heard that call out for second.
Hello, mate. You had trouble there.
Back engine there on your screen with a beautiful view of Earth behind it.
Bearing separation
What
confirmed.
the hell was that?
And we also just heard confirmation of fairing separation. As I
should
said
see
earlier,
them
those
fall
fairing
back.
halves
There they
are
go.
No longer needed. And you can see one there on your screen.
And
nice. Look at it.
Into the mission, Roman Space Telescope gets its first taste of space. Payload is jettisoned.
All vehicles are following nominal trajectories.
Yeah, I'm pretty sure that's the moon you can see in the background.
We are coming up on an expected AOS, or acquisition of signal, important step. Really just getting spacecraft's just sending its pulse over the NASA systems.
Yeah, that's right. The acquisition of signal should hopefully be coming up here in a minute or so. That'll be the first opportunity that the spacecraft can go and quote-unquote talk to the ground station, the folks back at Goddard, to make sure that it's still happy and healthy on the way during the stage 2 boost burn. But everything's looking good as far as telemetry is concerned for MVAC. So you can see there the nozzle extension glowing orange as it's going around the Earth.
I wonder if, like, you imagine if they find out it's like broken.
Carries the
could they carry on with the planned burn, not separate, and then deorbit it? I wonder if that's like ever been a case.
The Roman telescope won't really open its eyes, so to speak.
Stage 1 FTS is saved.
Until
Go on, show us the side boosters.
Out to that Lagrange 2
They're starting to come through.
From Earth.
Come on, show us the side boosters.
Everything that we're seeing, rocket performing exactly as it's supposed to.
It's coming through the atmosphere now.
NY entry burn startup.
And nominal trajectory so far. Very exciting moment for the space.
Oh, there we go. Oh, look at that.
That's for sure.
UI entry burn shutdown.
That is, honestly,
yeah, Steve. So
some of these like ground tracking shots
the entry burns
are absolutely beautiful. Look at that.
Way back to Earth right now. Now, as mentioned earlier, we will be attempting to recover both side boosters.
Look at it.
Are targeting a
so this is from underneath, guys.
And a
this is literally looking like directly up.
At Cape Canaveral Space Force Station.
Oh, wow.
You can actually follow the vehicle telemetry.
Holy cow.
Of those side boosters via the telemetry on your screen there.
Okay, that looks so weird, seeing it from upside down.
Now, we're just waiting for those landing burns to start up in just about 10 seconds from now.
There we go, we got both of them now. Imagine if none of the engines lit. There's one.
UI landing burn. NY landing burn.
Stage 2 is in terminal guidance.
Wait, so one of them's doing one of them did 3 engines down to 1.
PY landing confirmed.
Wait, where's the other one?
NY landing confirmed.
Guys, where's the other booster? Guys, where's the other booster? Have we had a failure on the booster? Have we had a...
We've got a beautiful shot of one of those side core boosters there on your screen.
Oh
We
my
did, of course,
God.
have confirmation of successful landings of both of those side core boosters, and certainly most people in the vicinity heard those sonic booms. Now, coming up next, we are expecting the shutdown of the second stage MVAC engine, and this is known as second engine cutoff one.
Okay,
or
maybe the
CECO1.
picture had frozen.
And we should be hearing that call out
Maybe.
here shortly, and afterwards we'll just be waiting for confirmation of good orbit.
Nominal orbit insertion.
I don't
And there's that
remember
call
the
out for
booster doing
nominal
3
orbital
down the
insertion
2 for
after we,
landing.
turned off the MVAC engine on the second stage there. So coming up next, we have a bit of a breather coming up before the next milestone for the mission.
Other one do
SCS
3 down the 1?
when the MVAC engine on the second stage restarts as it continues to its orbital destination. So let's hop back over to Megan and Dominic at the Kennedy Space Center in Florida. How did that launch look, guys?
Amazing. Almost didn't make it back here.
Oh.
We went
Words
outside to
cannot
watch it. It was
express it.
great.
In some ways, I could never believe that
Right,
this
I'm
would actually
watching
happen, and it is here and
both
far more
telemetries.
beautiful than I could have anticipated.
Yeah, how
Megan,
does it
I'm
feel?
so glad that we've done this.
Oh, I'm so
One
glad.
did
Thank
a
you so much
single.
for
Oh no,
you and
okay,
the-
one
oh,
did.
Yeah, no, thank you for sharing it with us.
3
and
engines
that
down
you
to
guys and
1.
The team have developed here.
And the other one done 3 engines
In order to provide
down to 1.
emotionally impactful and scientifically impactful imagery for all of humanity, and I feel like we have managed to achieve that today.
And now it is up in space, on its way there. Let's
Okay.
take another look at that launch, just in case you missed it. It was just 10 minutes ago from here at Kennedy Space Center.
1, ignition.
What?
And liftoff.
Right.
Go Falcon Heavy and go Roman Space Telescope.
This...
Again, NASA
I feel like the other booster...
will help answer some of the biggest mysteries in the universe. And in order to do
I
that,
feel like the other
go,
booster has had
more than
a
million
problem.
Miles away to a place called Lagrange Point 2 or L2. When can we start seeing data from Roman, Dominic, to start answering some of those ambitious questions?
I feel like something
Well,
has
Roman
happened.
is on its way, but a million miles is a long distance.
It
It'll
is.
take about 3 months for Roman to get out there. We'll be turning it on and commissioning the observatory as a whole so that when we get there, we can begin taking operational observations right away. And those data will start to become available in public around early 2027, and we'll be releasing them every day as we process
There was
the
no
data from then
photos.
on.
Can you wait just a couple more months?
We can wait a couple more months because we've got a heavy load of work to turn this instrument on and make it as amazing as it was designed to be.
Absolutely. And so, again, a lot to unpack about this mission. If you have any questions about anything that we're talking about, send them our way by tagging @NASA anywhere where you're watching this broadcast.
I'm so
Roman is a
confused.
flagship mission, as we've been saying, for NASA Science. With our Leah Martin now is Nikki Fox, an associate administrator for
There has
NASA's
been
Science
no
Mission
confirmation
Director,
of both
Sean
landing.
DeMoggle Goldman, NASA's Astrophysics Division Director.
Hi, Megan. Like you said, I'm joined here by Nikki and Sean, and I have to say I was able to watch your faces right after that mission launch. I don't think I have ever seen two people more excited probably to see a spacecraft lift off. So congratulations, first of all, to the both of you. Extraordinary launch, extraordinary being able to see your reaction.
Thank you. I think you're very kind not saying you saw both of us crying upstairs. But yeah.
Ah,
Incredible
right.
moment. So, Nikki, we've talked a lot
They're
about
looking at the wrong landing zone.
information that this mission is going to be able to give us. How is that going to bring us a little bit closer to answering those profound questions we have in humanity? Are we alone? Are there other universes like this?
Okay,
How
that's
correct
a
are
bit
we
strange.
about our own universe?
Absolutely. I mean, Roman is going to revolutionize the way we look at our universe. It is going to measure dark matter, which is, I know that sounds bizarre, but it's like the fabric of the universe. It's the thing we can't see, but we know it's there. It's going to measure dark energy, which kind of powers the universe. And they have that sort of a cosmic struggle between dark matter that wants to pull things together and dark energy that wants to pull things apart.
NSF.
And that will allow us to finally kind of explain our universe and understand our place in it. Not only that, it's going to find
NSF have cleared that it's definitely landed.
tens of thousands
Okay.
of exoplanets. Planets
Well,
that
that's kind of good because I
don't even
thought
know
we may have had a
billions of
issue
galaxies,
there.
tens
I
of
thought we'd lost the
billions of
booster.
stars. It's just a spectacular mission.
Oh my goodness, it's so poetic the way you lay it out like that. And Sean, for you, this is just one of many telescopes that we actually have in the NASA fleet. Tell us, how does this work together with
Hello, Highlands. Welcome. You've missed the launch. Literally just missed the double booster landing.
You want to get pictures of not just the forest and the trees, but the birds on the leaves and on the branches of those trees. We have special telescopes like
I was meant to be
Hubble
home
zoom
for
in
this,
pictures of
but
those birds.
you know,
And
I
we
am
have
in the
other,
hotel room
telescopes
still.
that do the panorama, that get the whole forest. Roman is a super
I get to have all the
powerful- a
fun
super- a
in the
superpower
hotel
telescope
still.
with both. It can get the whole forest and then zoom in at the exact same time and count the birds on the branches of those trees. And when you think about it, like once you're doing that, you're doing ecology, except these aren't birds and trees and forests. We're counting up supernova and galaxies so we can study effectively the ecology of the known universe the way that Nikki just described. So it's an amazing thing, and I'm just honestly thankful for just
I didn't
how
know
much
I had no notification.
I have their
Oh my
little
god.
fingerprints,
Yes,
but
we're
the
still
hearts
on
are so good.
holiday.
We're so thankful for all
We've
of
had
you.
to stay till Monday due to bad weather. So
congratulations.
it is what it is.
Beautiful, beautiful launch.
Thank you. It's such a good day.
Megan, we're going to go back to you.
I am as excited as they are, as well as those folks here right in front of the countdown clock. Again, 14 minutes after launch. Look at them there with their signs, waving, jumping. I love that
Oh
so
my
much.
God.
Oh, yes.
Again, so much excitement around this launch again because it can just discover so much we don't know about our own universe. So again, we've been taking some of your great questions live.
Seeing Roman.
Time for more now. Why don't we pull up the first one on our screen here?
Nice.
What other things will Roman be able to observe besides dark energy, dark matter, and exoplanets?
Oh, Megan, that goes to right what we were just saying about Roman. It has such amazing potential for discovery. One of Roman's surveys will be to look out into our own Milky Way galaxy. Looking at the plane of our galaxy, we can see with Roman's infrared vision all the way to the center of our galaxy and beyond and through and out the other side.
To
That's a
infinity
part of
and
our own
beyond.
galaxy that we've never seen in detail before.
Wow.
We will find tens of billions of stars, young stars, old stars, stars all the way across.
Guys, I'm
It is the
knackered already.
largest astronomical catalog in the history of astronomy.
Wow, I'm actually getting goosebumps. Look at it, goosebumps as you're talking about it, because again, just to discover so much is so intriguing. All right, let's take another question now.
Yes, what else do we have?
What will the next future telescope be like? Great question.
Well, the Roman coronagraph is designed to test out those new technologies, as we heard about from Dr. Jason today. It's a very complex set of new
no one. This
that will
is the
block
child
the stars
room.
so we can see the reflected light of planets orbiting.
No one's here.
Roman can see a planet like Jupiter.
I've nicked the
around
child's
a star
room
like
so
the
that
Sun.
they can
The next
be in the
observatory will
main
have
main
a
room.
similar chronograph that can detect an Earth around a sun-like star.
So smaller and closer. That's really
But we do have
So for more than 2.5 centuries,
our friendly
America
little
has
sailor
the
duck.
boundaries of space exploration, and it continues today with Roman.
The duck I brought my daughter.
250 years ago, 13 colonies
She
laid
left
the
you.
foundation for the greatest
Well,
and
she's
most
left me in the
enduring
other room,
democracy
yes.
in the history of the world. One driven by courage, faith, and freedom. From that moment,
Oh, God.
we became a nation defined not by where
2
we
seconds,
stood,
guys.
but by how far we were willing to go. We conquered vast frontiers, invented tools that shaped a modern world. We found light in the dark, and we rose from the earth. Faster, higher, farther. We pushed beyond the sky and into the unknown. Today, our curiosity stretches farther than ever. American robots search ancient rivers on Mars. New telescopes unfold to glimpse the first stars. For 250 years, America has carried the light of humanity forward. But American exceptionalism isn't inherited, it's earned. Our greatness comes not only from what we've done, but what we're still determined to discover. Because
You
in
didn't
every
see me
era,
streaming.
across
Oh,
every horizon,
Troubles,
America is at
terrible.
its best, when its reaching
You know, I'm always
its
going to be there for a big launch.
America celebrates 250 years, and we are leading the world.
Do you know,
into the
I've only
future.
just realised what the GTSY means. How has it taken me this long to see,
Roman will help us study
to
things
understand
like
that?
dark matter and dark energy. But again, we've been saying they're
Oh.
invisible. So how do you see things like that? Well, Roman will use gravity as a tool, and Dominic's going to explain.
Gravity
Well,
as a
Megan,
tool.
everything in the universe that has mass
Yeah,
has gravity
yes,
associated
really.
with that mass. Gravity bends light, it distorts
To be
light,
fair,
and
I've not really
therefore
normally
distorts
taken
images.
any
So
notice
when
of
we
it.
look out into the universe, past all that dark matter, the gravity of that dark matter distorts the images of the galaxies we see beyond it.
Oh.
And so we can use this as a tool. When we measure the distortions of those galaxies, we can infer the dark matter
The
between
Mac didn't
us
like that
and
then.
them. And we can make a three-dimensional map of all of the foam of dark matter that's out there.
Is
in the
Lance on
universe.
holiday with you? No, he's not on holiday, no.
Visual way to show this.
It's just me and the
Yes, thank you.
family.
I'm a visual person.
It's a great thing. So since
Yes,
we're going to be
Highland,
ready
yes.
to celebrate, we have our champagne flutes.
Oh,
The
God, here we
champagne
go.
flutes will be our dark matter.
Okay.
They're clear, right? It's invisible.
Sure, invisible.
More or less invisible. And our galaxies will be our iconic Roman Space Telescope logo.
Okay.
Now, the pattern of galaxies is a little like the pattern of letters. It's
Mm-hmm.
recognizable. You know what letters should look like.
Mhm.
But when dark matter intervenes between us and those
No,
letters,
Highland,
those
no.
galaxies,
Mm-hmm.
as we distort the imagery,
Oh,
you
yeah.
can see the words space telescope are distorted by that dark matter.
I see.
And we can make those maps.
Yes, no, I
And we can
feel
then
very,
see
very
where the
refreshed.
dark
I tell
matter
ya.
is distorting the
I
distant
actually
galaxies
kind of now
and
can't wait to get
infer
home.
where that
Just
dark matter is.
Right.
Just like
to
you
be
could
able to have
figure
a
out the word
big bottle of
space
fizzy.
and figure out
The
how much
fridge that we've got
glass
here is
between
tiny.
the camera and this image.
What about?
So again, you might not be able to see the dark matter, the dark energy itself, but because it's distorting things behind it, you're like,
I don't know.
Yes, because dark matter moves the light
Tubbles, yeah,
around,
that's
just
a bit
like
not
dark
safe for
energy
work.
moves
Yes,
things around in
definitely.
space. We don't see them directly, but we see their impact on the universe. And since dark matter and dark energy are 95% of the total matter and energy that's out there, they dominate everything.
Oh my God.
All the stars, all the galaxies,
Guys,
they are there because dark
shall we
matter
quickly
and dark
go for a
energy has
walk
pushed them
and I can
pulled
show
them
you the view
here. And
that
we
we've
would like to
got? Give me 2
understand how those
seconds.
work, because that gets at the very fabric of our universe. How did the universe come to be
We
the
can
way it
hear.
is?
sure, really clever. A clever
Let me
tool
quickly
that
go
we're
to
using.
the
Now,
part down
Roman's
there.
wide field instrument will use this technique along with other
So you can
methods
still hear
to
me.
explore our universe on an enormous, unprecedented scale. But why does seeing that much of the sky at once
Right, guys.
matter? Leah is back with her next
We're going to
guest. Leah.
quickly pop and show you
Good
guys
morning, Megan. Nice to see
the
you again.
view
I'm here
I
joined
have.
by Ami
Um,
who's actually our wide field instrument scientist here on the Roman mission. Ami, thank you so much for joining us today. So we just saw Amy and Dominic demonstrating how
Hi.
this wide field instrument actually works, but why do we want to map the sky on this scale? What does it
Oh, yeah, of
actually tell
course.
us?
To understand the
Right,
universe's biggest
let's turn this
questions
on.
about dark matter, dark energy,
We're going to go out the
and
door.
planets beyond our solar system, we need
And we're
both
going to go down
the
the
finer
hallway.
details and the really big picture. And imagine photographing a
this.
landscape, as Sean just mentioned earlier.
I love this.
Instead of just a single tree here or a mountain peak there, we get
Right,
the whole
we're gonna go
picture,
down here.
and those patterns that are revealed can help us put the whole picture together.
And how is this different from other instruments that we have currently in space? We talked a little bit about the
There we
different
go.
instruments that are on, but how does that are on Roman? But how does this one actually work differently?
Look at that view, guys.
Roman
Hang on.
combines Hubble's sharpness,
Let me just-
but with 100 times the field of view. And so that means we don't lose the finer details, but we can very efficiently
Is it
map out
blur?
the sky.
It's blurry, isn't it?
Like very large volumes of the sky.
Yeah.
And we can also point
I
at
can
a
see
new location
France.
with Roman and settle down very quickly. And so we
Do you know
spend
what the
more
thing
time
is?
taking pictures than just waiting.
I can see some
So
big,
with the speed
like,
of light,
cargo
we'll be able to
ships,
get
I think.
more of that data, we'll be able to get
And this
more
is
of
how
that
high we are,
to
guys.
understand and kind of unravel some of those mysteries.
Like, we're like
That's right.
6
So
floors
right
up,
now
I think
we
it
know
is.
about 6,000 exoplanets, but how many more are you guys anticipating that this wide
Literally,
field
this is
instrument
like
will
the
reveal?
perfect place to come at
We're
night time
anticipating around 100,000
because it's
new,
like
previously
pure
undiscovered
darkness.
exoplanets. including about 1,000 that will be revealed through.
Yeah, we might go to the
microlensing,
beach
so
later
called
on,
gravitational lensing.
and I might do a little
And
live
so
stream
we will
from
learn a
the
lot
beach.
about cold, rocky planets.
There's a nice, I keep seeing it
and
every day.
potentially some in
There's
the
a really
habitable
nice Land Rover Defender 90
Really? Okay,
down there.
so
It looks so
you're
nice.
actually looking. Is this
Actually,
going
where
to be
is
used
the
in
shop?
conjunction maybe with the other habitable
It's a little
world
shop that we keep
story
going
that
to.
we heard,
It's just down behind that big building.
That's right. And
It's
it'll help
so
pave the way
nice.
for habitable worlds.
Fantastic.
Right.
Thank you so much for joining us today.
See, I like I
And,
can actually like walk
Megan,
around.
We're going to send it back to you.
That's really. Is that a bright light or is that a reflection?
Minutes after launch, and they're still so
Oh
excited
God.
to be here as we continue to follow along as the
So I've got
Falcon
my.
Heavy
We're gonna do
continues
that
its journey
tomorrow
around the
night
sun.
now.
So let's head back to SpaceX for that next operational
Okay,
milestone.
that's gonna just stay like that.
Thanks, Megan. Now,
Do they
just to
speak English
recap
where you are?
everything
Yes,
that's
they
happened
do.
So far,
They
we
do
had
speak
an on-time
English.
liftoff of Falcon
It
Heavy
is still
from historic
a
Launch Complex 39A in
UK
Florida
territory.
at 7:26 a.m. Eastern Time. A few minutes after that, we
Alright, let's go
jettisoned
back
the
to our
two
room.
side cores, with the center core jettisoned shortly after. And those two side core boosters performed
There we
pushback
go.
burns and made their way back to Florida for landings at Landing Zone 2 and Landing Zone 40. And you can
Yeah,
see
Charles.
those there on your screen, Landing Zone 40 on the left and Landing Zone 2 on the
Right,
right.
here we go. We're
And
back.
the second stage performed the first of two burns, which lasted about 4.5
Are they
minutes.
your cousins,
Next
Cal?
major milestone coming up in just under 30 seconds from now will be the second engine light on that
Scottish?
MVAC,
No, there's no Scottish
and
people here.
that burn is set
Actually,
to last
no, there
for
was
about
actually
2
Scottish
minutes, and will
people
be the
here.
second and final burn of those two burns needed to send the Roman
Last
Space
night in the
Telescope on its
entertainment,
way
there
to
was
the
actually
Sun-Earth
Scottish
L2
people.
point. Now, as mentioned
Right,
earlier,
guys, I'm going to be
L2
back
is
in
the
2
launch
seconds. I
point
just
on
need
the
to put to the
opposite side of
toilet.
Earth from the Sun, which is
I'm going to make sure I
approximately
mute my mic.
4 times farther from Earth than the Moon. So we should be hearing that call out for SES-2 momentarily. Now, we are, of course, able to monitor the vehicle's telemetry via the graphics that we have at the bottom of your screen there. The engine that is currently firing is, of course, the Merlin vacuum or MVAC engine located on the second stage. Now, this engine has a much larger nozzle than the sea-level M1D engines located at the bottoms of the 3 boosters that made up the first stage. Now, we unfortunately don't have views of that engine burning right now. Now, that extended nozzle allows for optimal performance of this engine when operating in the vacuum of space where there's no atmosphere to burn in. Each M1D engine can produce a max thrust of about 190,000 pounds of force at sea level, whereas this MVAC engine can output about 220,500 pounds of thrust in vacuum. Now, we've still got about 30 seconds left of this MVAC engine
Right,
burn.
I'm back, guys.
Taking a look ahead in the mission, about 5 minutes after the conclusion of this burn, we will then have payload deployment of the Roman Space Telescope, and that deployment is set for the T+31 minute and 31 second mark.
Oh, God, I'm so
We
tired.
should be hearing that call out for SECO 2 in just about 10 seconds from now.
Nice. Man, I'm absent. Wrong songs. I love it. Right, can I
And just
take
standing
one
by for that
AirPod
call
out
out.
without it causing trouble? I think so. Oh, it paused the video.
Of SECO 2.
Right, there we go.
On your screen right now, you can
Nominal
see.
orbit insertion.
And there we heard
Headphones
that
still
call out
working.
for nominal orbital insertion.
Nominal orbit
One more major
insertion.
event coming up, which is the most important one, and that is, of course, payload deployment of the Nancy Grace Roman Space Telescope in just under 5 minutes. How are things looking over at Kennedy, Megan?
Hey, Zach, it's looking really good over here. It's exciting to see that we're
Like
nearly
his
there
side of the
with the
family.
Falcon Heavy see live images of Roman's deployment into space. Now, we
I
just
love
told
it.
you about Roman's Wide Field Instrument, the mission's primary science instrument.
Ow.
But Roman has a second instrument, and that is its coronagraph, a technology demonstration designed and built by NASA Jet Propulsion Laboratory to test how we can block the bright glare of a star to see the much fainter planets orbiting around it. So, Dominic, that could eventually help future telescopes. We were talking about this before. Maybe find
Ow.
other planets.
I've
like
really
our
got
solar
like an
system
itchy
like
leg. I think I've been
Megan, this is an
stung.
extraordinarily challenging problem. You saw in that little
I've
video
been
there
bit or
the
something.
planet being lost in the glare of the light of a star.
Yeah, guys, you'll love the
is
view we've got
10
from the
million
child's
times fainter than
bedroom.
the star that it's around.
Is
Wow.
literally
Like Earth is
someone else's room.
billionth
Oh my
as bright as the star. So you have to
It's
block
so
that
funny.
starlight exquisitely. The Roman coronagraph demonstrates all the technologies necessary to do this for the very first time in space.
Wow.
And a future telescopes that have
Guys,
the
I'm
full
so tired.
observatory will then carry that
The only-
forward to measure the light of an Earth-like planet around a Sun-like star.
Oh yeah, no,
and tell
I
us
have been in
whether
the
there are potentially signs of
pool
life on other
like
worlds.
every single day we've been here. We got here Monday.
Pushing the boundaries of capability and knowledge.
We didn't get time to go in there, but since Tuesday, we have been in the pool every single day.
Our broadcast will end shortly after that, but you can keep learning more about this mission here.
Get ready for NASA's new view of the universe and the Nancy Grace Roman Space Telescope with a special limited series of NASA's Curious Universe.
So you're asking for the 10-second description of how the universe entirely works.
We're
Somebody started cooking fat. Yeah, that's true, yeah.
It's never been built before. No one's going to build this
No, I
again.
just smell of chlorine now. That's all I smell of is
Find the
chlorine.
story behind Roman at nasa.gov.
It messes up my hair, like my hair
Wherever you get your
gets like really sticky. It's
The
horrible.
idea of pulling back the curtain on so much of the universe that we still don't know yet is super intriguing, not just for scientists, but also artists too, like singer-songwriter Jewel.
It's Jewel, and as you may know, I
Who the hell?
using astrophysical data, and there would be no data more fascinating than dark energy and dark matter. And so it is with this
Are you George Michael with that hair?
and Godspeed that I wish
No,
that
I need to
Nancy
get a
Grace
haircut. That's what it is. I need a haircut so badly. I was going to get one here,
Separate from the Falcon
but
Heavy
it's
second stage, so let's watch that moment
£35
unfold with Steve.
for a haircut here. Like, it's ridiculous.
We are about a minute and a half away from that expected separation of the Roman Space Telescope from the Falcon Heavy
Right.
second stage that has gotten it into orbit and on its way to the Lagrange 2 point.
Okay, we've
exciting
got
morning.
confirmation behind.
So far, so good. Everything's been right down the middle.
It suits
as
me,
far as
really.
Stage 2, burn 1, and burn 2.
And I'm not too keen on like the slightly
really great
longer
so far.
hair.
And also,
And you get my
did
sides
get
done at least.
confirmation- We did get confirmation from the spacecraft
Oh,
itself early in the launch, around 7 minutes or so.
There you go.
first
It's going down.
Signal or pulse from the spacecraft. That was a big milestone as well. As we.
To be fair, I've always
for
had
another
a
30
high
seconds,
hairline.
I'm sorry, another 30 seconds before that separation comes. Roman is of
All right,
course,
we're almost there.
recharging its batteries on solar power, and looking forward to that flying free on its own.
Yeah, hopefully we'll get a good shot of stage 2 here. They usually have a great forward-looking camera from the top of the stage 2. And there we go. And we have a shot of
Probably, yeah.
mission director.
I probably do get it from my parents.
Let's see if we can see.
Right. Oh, wow. Look at that for a shot.
Telescope separation
Beautiful.
confirmed.
Wow.
Nancy Grace Roman Space Telescope flying free on its way to Lagrange 2.
That is a very cool.
And of course, a lot of celebration with the team.
Yeah, oh,
Jared.
he has a
You,
massive forehead.
You represent a lot of people in NASA's launch services.
Like,
program.
people see his forehead and they think
lot of
it's
work
a
goes into this.
solar eclipse.
I hope you have enjoyed it. We've enjoyed having you.
Yeah, it's been great. Yeah, wonderful spacecraft deploy.
Wow.
Heard all the claps here behind us in the mission dress and in the mission control room. I'm sure the same at Goddard. Thanks so much for having me today, and most importantly,
Damn,
try
there
to
we go,
respect
guys. The
over
Nancy
being an
Grace
astronaut
Roman
throughout
Space
this program.
Telescope
It's been great working
is
with
in
everybody, and
orbit
we can't wait
and
to see all the
released
great
to
science
where
that you're going to do out
it
there.
should be going, and
It's
now
going
it
to be
will
terrific.
do its
Roman is
own
on its way, and we're going
propulsion
back to Zach at Hawthorne, California, and SpaceX.
to get to its final resting place.
Thanks, Steve and Jared, and what a spectacular deployment. Of course, a huge thank you from SpaceX to everyone at NASA for the
I'm gonna
partnership
sneeze.
on this mission, and to all of the teams on both sides who brought NASA's Nancy Grace Roman Space Telescope to the pad and into space. Now, with the launch
Oh my
completed
god.
and successful deployment from our second stage, that's going to do it for me here in Hawthorne.
Yeah,
I'll
exactly,
hand it
yeah.
back to the NASA team from here. Over to you, Megan.
Yeah, the way you got to think about our father is he's like Homer Simpson. He's only got a few strands of hair going across.
onto a trajectory towards Lagrange Point 2 or L2. And now the spacecraft teams will take over, so let's hear from Leah with her last guess.
Megan, I'm actually joined here by Jeremy Perkins.
I
who's part
love
of our
it,
science
yeah.
commissioning team, and I have
It's
to
not
tell you
long till
something that's
Christmas
funny that
now.
just happened. He walked in right after launch, and he was showing me on his watch this really interesting pattern of a regular heart rate, then right at 7:26, this huge spike. So super exciting day for you, super exciting day for your team. We launched just about half an hour ago. Hope your heart rate's starting to settle down just a little bit. So things here are starting to simmer, but it's actually
Yeah, no, yeah, definitely. We'll glue PVA glue them
what are
on.
you guys doing now? What's next on the board?
Yeah, so coming up in the next few hours, I think I just saw the video of us deploying from the rocket, but we contact and then we get our solar panels pointed at the sun so we can make sure we get good power going to the system because we're on internal power right
See,
now.
the thing I don't like about long
Over the
hair
next day or so,
is it goes over
we're
my
gonna do
ear.
a mid-course
I
correction
hate it.
where
I
we
hate
make
it.
sure we're in
Touching
the
my
right,
ear.
way to get to L2, about 1 million miles from Earth. And then over the next days, we're going to be deploying our high gain antenna, which is about as, if you were watching the video just now, you saw it as we were going away from the space vehicle. It's about as round as I am.
Satellite dish.
And
Yeah.
that's just to get down the amount of data that Ami and other folks talked about earlier, back down to the ground.
And how much data are
You,
we talking about?
So we're
you
talking
look
about
like...
a terabyte of data a day from L2. So the way that I like to think
That'd
about
be
that
so
is
funny.
100 million songs that we're
It'd be very
streaming from
funny.
1 million miles away every single day for the lifetime of Roman.
Oh my god.
Now, the team of engineers who are responsible for designing and building the spacecraft are actually watching this unfold right now. What are they looking for?
So like you said, the folks that designed, built, and integrated Roman are actually sitting on console right now and just paying attention to every little detail about Roman. There's thermal engineers that are looking at all the temperatures. There's folks in making sure the deployments are going okay. There's folks that are making sure the communications are working.
No, Jersey,
So
they
there's just a whole
like
crew of
gingers
folks
here apparently.
here on campus at Kennedy and up in Greenbelt and all over the country that are actually monitoring Roman as it goes out to.
And this is kind of their first look because some of this instrumentation actually hasn't even been used or tested since it was first in before it was ever even integrated.
That's because your team shit, not that it was
Correct.
boring.
The last time we've really turned the instruments all the way on was back when we did thermal vac months
So
ago.
it actually uses the solar panels to like block out the light. It's pretty cool actually.
That official handover.
And there's like a hood as well.
The checkouts to the science team.
Yep.
Tell us a little bit about
That
the
is
timeline.
very
What does that
cool.
look like?
Yeah, so we're going to be checking out Roman for about a month, and then we're going to be aligning and focusing the telescope, making sure we get all the pointing right, and then we get into science commissioning, like you said, and that's where we're really just
solar panels definitely for sure. On the sides.
And doing that handover from engineering to science, which is when the science team really starts to get involved and really understanding.
And then we get those images, and we're going to be sharing those with the
Would
world.
be
So
quite
Jeremy,
funny.
Thank you so much for being here.
I'd
Congratulations.
love to see the old
your
man
team.
flirt.
And Megan and Dominic, we're
God.
going to send it back to you.
Charles crying. Oh
I'm
god,
sure that if these folks also had something that Jeremy was wearing to track their heart rate, there would also be a spike around that time. Again, 36 minutes ago when there was launch of Roman right from here at Kennedy Space Center. So, Dominic, I want to take time to take more questions. We had so many of you send in great questions throughout
Oh
the
my god,
broadcast.
how long is this going to go on for, guys?
Let's take the first one.
Absolutely. What do we have?
How would repairs or refueling Roman work given the distance of the telescope from Earth?
It's a great question. We did design Roman to be at least refuelable so that its fuel ports are accessible. A sufficiently advanced robotic refueling spacecraft could get out there to 1 million miles away, could rendezvous and dock with Roman, grapple with it, and add more fuel. That could extend its lifetime to give it even more time to map the cosmos.
But is that the plan to refuel it? Hopefully not.
We don't have a plan to do that, but we designed it in so that it could be possible. We didn't want to preclude the possibility of extending the lifetime, but it relies on servicing capabilities that are still in development.
Yeah, I said hopefully not because it's perfect. You made a perfect
It is
spacecraft.
perfect, but we want even more of the perfect.
All right, let's take another question now. Let's see.
Hey, could you imagine if they get to extend it like even longer?
Oh my God, what light spectra does Roman operate with? So sorry, guys, terrible vision I have.
That's fine. So the Hubble Space Telescope was designed primarily for ultraviolet
Visible
light.
yeah.
It extends a little bit into the infrared. The James Webb Space Telescope is designed to focus on the infrared and out into longer wavelengths. Roman bridges
Oh
that
God,
gap.
the child's
It is
really not
sensitive to
happy.
light in the near in the visible range, and say orange light, but it goes further out into the infrared than Hubble can. And with that infrared vision, it penetrates through clouds of gas and dust and sees farther into our galaxy or into star-forming regions than has been possible with visible light.
Wow. Okay. Well, and again, remember we did ask some folks to vote on Twitch about what
Yes, we
they'd
did.
be most excited to study. Roman would be most excited to study. So let's pull up you guys' answers now. Again,
Let's see what the vote
dark matter,
was.
planetary systems. Oh, that is not
Yeah,
surprising.
dark
there.
energy and
dark
dark matter.
energy and dark matter, Dominic.
That is what we built the mission
Nice.
to do, among other things, and it's part of the key questions about the universe, the fabric of space and time that Roman will unlock for us.
Yeah. Again, there's just so much we don't know about it. So, of course, there must be so much curiosity around it.
Are we waiting for
There's so much
something
out there
to
to
happen
discover.
with this
We
rocket?
do
No,
not
we are
understand
just
a lot about the
waiting until
universe,
they
and Roman
end
was
their
designed to
stream.
give us the data we need to answer
It's sort of
countless
good just to sort of see if they
And
come
then
up with
another quick
anything.
note, don't forget about Roman's Adopt a Pixel campaign. We debuted
Oh
it
yeah, if you
earlier
want
in
to
this
adopt a
broadcast.
pixel
single
of
Roman
the
image will have
telescope,
300 million pixels.
you
And we
can
are inviting you to sign up
adopt
for
one if
one
you
of those
want.
pixels by visiting nasa.gov/adopt-a-pixel. Again, how cool is that? Your own cosmic dot
That is
in the
very,
universe.
very
I
cool.
hope you're going to sign up.
Oh, absolutely, Megan. I
I
don't know
might
what
do
my
it.
pixel will contain. Will it be a star? Will it be a galaxy? Will that star explode? Who knows?
Yeah, will the star
Which one
explode?
will
Yeah,
you
that would
adopt?
be great. I would love anything. I mean, I just think it's so great to call, to be able to call some part of this beautiful images that we're going
There's
to
a
see.
massive
sign
knot
up.
on the
So
guy's
that's a
tie.
really fun campaign. Thank you to those who developed it.
There's a massive knot
All
on the
right, so
guy's
that's going
tie.
to do it for us here
Oh
at Kennedy
yeah,
Space
he's done
Center
the
with
like
live coverage of
fan
NASA's
type knot.
Nancy Grace Roman Space Telescope mission. A huge
I didn't notice that
congratulations
actually.
to
Well,
everyone
well done,
involved, and
Highland.
a big thank you to everyone who
All right, I think here we
participated
go.
in
They're
the
going to end their
broadcast,
stream
and
now.
especially to you, Dominic. It was so great having you.
Oh, I
It
see
was
blue
thrilling
sky,
to be
guys.
here with you, Megan. I couldn't
I
have
see
had
blue
a better
sky.
partner to go through this launch with. It has been an amazing day. Roman had a beautiful, picture-perfect launch. It's going out on its way to space, where it's going to do fabulous, fantastic things.
And we just want to give a shout out again to the teams over at Goddard. We had our launch support room over there specifically supporting launch operations, and then we also had the mission operations room. Oh, they're waving now. Congratulations to you all.
Yes, we can see the launch support room on the right and the mission operations room on the left. Those people are hard at work preparing the observatory, already operating, and over the next several months we will have a hotbed of activity, especially in the mission operations room that you see there. I'll be sitting in there some of the time as we get the first data back and tune up this observatory to do spectacular, world-changing things.
Oh God, my poor child.
Is power positive. Can you tell us about that?
Ah, yes. So that
She's
means that
either
these solar
tired,
arrays are
hungry,
actively providing electricity.
or just
It's no longer
bored.
running off of its internal batteries. In fact, hopefully it'll be recharging them at this point.
Each one of
That's
us are keeping up.
necessary to
Yeah,
all
exactly.
the
Yeah.
to keep the observatory running smoothly.
Oh my gosh, that's so exciting. Oh, again, I'm getting
Yes.
goosebumps. It's so cool to see what we can accomplish together and what NASA continues to do
Yes.
to advance what we do in air and space. So we invite
poor
you now
child.
to our post-launch news conference. That will take place at 9:30
right.
a.m. Eastern Time on NASA's YouTube and X accounts. We will have NASA leadership and Roman scientists on to answer any of your questions.
Oh, we're
And
not going to be
remember,
doing
launch
that.
might be over, but the mission has just begun, as we've been just telling you about. That team of people at Goddard continuing to follow along with
Goddard.
the mission, and you can continue to follow along with us on this groundbreaking journey by going to nasa.gov/Roman. You're definitely going to want to check out the live
Nice.
broadcast when we will reveal Roman's first images. We're aiming for
We will
early
definitely
2027, Dominic.
be there for that
Those
one.
images will be iconic in the same way first images from
A
Hubble
child, yeah,
and
yeah,
Webb
yeah,
have
yeah, yeah.
permeated the nations and the world's consciousness. Roman is going to do that on an unprecedented scale.
Yeah, let's discover new things we
Nice.
don't yet know about our universe. Until
Oh,
then,
come on,
have a
guys,
great
just
day and
end
go Nancy Grace Roman Space Telescope.
when that
Go
will be
Roman.
early 2027. So it's going to take about 3 months for it to get
15
to the
seconds.
point where it's going. Oh, we get a highlight of the rocket launch.
T minus 10, 9,
I
8,
think they actually turned the
7,
wrong camera
6,
on for
5,
the landing
4,
zone.
3, 2, 1, ignition, and liftoff.
I can't
Go,
wait that
Falcon
long.
Heavy, and
But you're
go
going to
up
have to,
space
Highland,
telescope.
unfortunately.
Vehicle is pitching
Look at,
downrange.
look at the Starship Tower in the background. Just looks absolutely mad. All right, there we go, guys. It is done. Right, guys. Gonna have to wait. Right, guys. Thank you very, very much for joining me tonight. Today, even. I'm so used to saying tonight. Right, guys. Join me. I don't even know when the next bloody launch is. Tomorrow, 1 p.m. I might be able to do a non-commentated live stream. It depends if nice to see you, George. George, who the hell is George? But yeah, no, we. I probably won't be able to do. I might be able to do the live stream tomorrow. It depends what we're doing. So, because tomorrow we get kicked out of the hotel. Oh, George Michael. Yeah. Sorry, I'm well off with it. So my next stream will be Wednesday. Careless whisper. My next live stream will be Wednesday, where we'll be back doing GeoGuessr. Just keep an eye out for any vertical live streams from my phone. I might go out tonight again, do a little stroll down the beach. And yeah, right, guys. Thank you very, very much for watching. I'm Lee. Fly safe, land safe, and see you guys later. Bye.